The demand of analytics engineers is growing rapidly, and you know what? This data role is more AI proof as compared to some junior data roles. Ansh, I also want to become an analytics engineer, but I do not know from where to start and exactly what to cover. What are the tools, frameworks I need to know? And I do not have any kind of structured guide. Do not worry. That's why I have created this complete masterclass. And first thing first, you first need to understand that analytics engineering is a complete domain in itself, and you need to grow step by step in domain. And your very first step is actually gaining a very strong foundation around all of the concepts that we use in the analytics engineering world. And that's why I have created this complete 4+ hours long masterclass for this domain, including these topics such as what is actually an analytics engineer role, the complete data lifecycle, ELTL, blob storage and data lake, open table formats such as Delta Lake, Lakehouse versus warehouse, configuration-based incremental loading, backfilling of data, applying upserts over appends, what is Apache Spark and why we need to use PySpark, relational data modeling and dimensional data modeling, Apache Airflow and Azure Data Factory for orchestration, slowly changing dimension and its types. Not just this, we also gonna learn about a very popular framework within analytics engineering, which is DBT, and we will perform an end-to-end example as well with DBT and Databricks. Wow, that is a complete course in itself. But this role is only for those people who are already in the data domain and who are ready to learn more, because you need to learn a lot of new things if you just want to enter into this domain. Why? Let me tell you. Because this is a role which requires much more skills than a data analyst knows and lesser skills than data engineer knows. So this is a sweet spot between a data analyst and data engineer. But yes, the demand is growing and the supply is very less. So if you are ready to learn and upskill yourself and you want to actually enter into this role, then this masterclass will help you in all of the possible ways, with amazing hand-drawn doodles to explain the critical concepts, with notes, with demos, with everything, and obviously for free. So without any delay, just take out your notebook and just start taking notes, because we gonna learn so much in this particular amazing masterclass.
So what's up my fam, happy Sunday, and finally Analytics Engineer Masterclass is here. First of all, let me just tell you, analytics engineering as a domain is growing rapidly. So if you are a beginner, yes, this video is for everyone who is a beginner, because this is a beginner friendly video. So just relax. You do not need any kind of prior knowledge to get started with this thing. Simple. Okay, obviously you should know some basic stuff, Python, SQL, and all of your beginner level stuff that you do in the data domain, obviously. Now let me just tell you one thing, that this video, this masterclass, by the end of this masterclass, you will be able to build a strong foundation for your entire analytics engineering domain, which will guide you that what exactly you need to know, why you need to know, and each concept will be crystal clear in your head, so that you can just start learning deeper and deeper and deeper inside those topics. Make sense? We will also talk about popular tools, yes, your favorite tool DBT and all. We will just talk about most of things, and let me just tell you the agenda quickly, that what exactly we're going to talk about. But I hope that this analytics engineering masterclass will help you in every possible way if you want to become one. Simple, very simple. Okay, and obviously the resources will be there in the video as well, so it's fine. So let me just talk about the agenda, like what topics I am going to cover in this video. First thing first, I am going to cover the analytics engineer role, because you first need to understand who is actually an analytics engineer, what the person will do after becoming an analytics engineer. So you need to understand that thing, and you will get to know that the supply of analytics engineer is less. Why? And why you should just target this role as soon as possible, because there will not be like much openings for analytics engineer roles, because this is a kind of senior role to data analyst but junior role to data engineer. So time is less, you have to hurry. Then we're going to talk about data lifecycle, the entire data lifecycle, because when you are targeting such a role which requires more expertise than just data analytics, you need to understand the entire data lifecycle. Then you will get to know about ELTL, which is the modern way of performing all of the things. Then you will get to know about blob storage versus data lake, which is the modern data architecture that we do in storing and retrieving the data. Then you will know what exactly is a lake house, then open table formats and all of the other table formats that you need to work with the modern data engineering. Because see, when you are just working as a beginner, or let's say you are a fresher, or let's say you are a student, you would have covered the fundamentals like SQL, Python, databases, queries. It's fine. But when you actually perform the tasks in the real world, it's not the case. Why? Because the things that you are reading right now in the books were written like 20 years, 15 years back. But now the architecture is completely changed. We talk more about the open table formats, abstraction layers, data lakes, ELTL, lake houses, these things. Make sense? Good. That is why this video is for you. And then we're going to talk about incremental loading, and not just the traditional incremental loading, the modern way how to incrementally load the data using configuration files. Then we're going to talk about backfilling, which is a very popular step that we all developers perform. Then we're going to talk about upserts. Then we're going to talk about Apache Spark, which is the most popular distributed computing framework, and PySpark as well. Then data modeling. Here, this data modeling chapter is very special for you, because here you will learn that data modeling is not exactly what you are thinking right now. Data modeling has different flavors. Data modeling is also that data modeling where you perform normalization, first normal form, second normal form, third normal form. But on the data engineering side, on the analytics engineering side, we do not perform that data modeling, not at all. That will be done by DBA. We perform in the form of facts and dimension tables. So this will be a very thorough chapter. Then we're going to talk about Apache Airflow and Azure Data Factory for orchestration. Then yes, we're gonna deeply talk about DBT, because DBT is the backbone of the entire data engineering or analytics engineering domain. Not data engineering, but analytics engineering. Then we're going to talk about SCD types, basically slowly changing dimension types. And we also going to see one demo of Delta Lake, and I will also show you end-to-end demo how you can just work with DBT with Databricks or any other platform. So this is a thorough, complete masterclass is made for you for all of the future analytics engineers. Simple. Expectations are clear, agenda is clear, everything is clear. Very well done. Now let's get started with our masterclass, and we have to congratulate our newly people who have cracked that dream offer. So simply say congratulations, 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 and congratulations. And one more, one more, one more, one more, one more, one more, one more. Whoa, wow. Great list, big list. I want this list to be like more big. So now the thing is even more bigger. So now the thing is, first of all, congratulations to all of these people. If you want your name to be here, you just need to do one thing. What is that one thing? Learn, learn, and learn. There is no alternative of learning. Simple. And especially in the AI era, AI is taking jobs, yes, but not of those people who are actually learning, who are actually adapting with the technologies. Simple. And you will also get to know why analytics engineering role is actually AI proof, because I have mentioned some points which will actually show you the reality. Okay. And this is me, Ansh Lamba, in front of you. And now let's get started with our masterclass on analytics engineering. Let's get started. So whenever we talk about analytics engineering as a domain, or you can say analytics engineer as a profile, you first need to understand who actually is analytics engineer. Simple question. So this is a very sweet spot that is obviously growing right now. First thing, obviously that's why we need to just learn about this. Second thing, when you will look at the roles and responsibilities of this particular profile, you will love it. You will literally love it, and you will actually feel why I like myself didn't jump into this domain earlier, because obviously analytics engineering was not there, but that's not the case. people were actually doing the same stuff before as well, who understood the importance of growing and learning new and new things, to be honest. So let me just first of all tell you this particular thing. Who is actually a analytics engineer? Who is an analytics engineer? And obviously this is a kind of self-explanatory profile with its name, but let's talk about it. Let's say in your organization, you have a data team. Obviously, every organization has a data team. Now in that data team, you have some data engineers. Very good. Very good. Let's take a sample of individual person. Okay. So let's say this is one data engineer, and this data engineer does the data engineering things like pipelines, automation, ELTs, data warehouses, lakehouses, all of that stuff. Very good. Now there is a data analyst as well. Okay, obviously. Now this data analyst, let's keep this person here. Okay. Because this is the upstream and data analyst is the downstream, because data analytics team is like the stakeholder for data engineering team. I hope you have this basic understanding, but do not worry, we're going to cover that as well in the data lifecycle. So do not worry at all. So let's say this is the data engineer. Okay. And now we have one data analyst. Let's say this one. Okay. Let's say this is the data analyst. Make sense? He's cute. Now this data engineer is working on the data engineering tasks. This data analyst is actually working on the data analytics task. Now what can be data analytics task? Now I know in each organization the roles and responsibilities can differ, but most probably this person would work with, let's say, Power BI just to build the reports. This person would work with obviously SQL to retrieve the data, to analyze the data. Simple. This person would also work a little bit with Python if person is using pandas, obviously, because in all the organization not everyone uses Python a lot, but I am assuming that you are using Python. So this is like most of the things that a person use. And now someone will say Excel bro, Excel is okay, let me just write Excel. See, happy use Excel is everything. Yes, use Excel is just a, you can say, kind of source of data. You do not need to build Excel models, macros, and all of these things. If you are doing this, wow. So this is, let's say, the stack. Okay. This for this data analyst makes sense. Now what will happen? Now we have a new role, which is called analytics engineer. Now this analytics engineer, let me just bring that person. Let's say this is the person, this one. So this analytics engineer person, which is standing in the middle. Now this person, this analytics engineer, why this person is actually sitting in the sweetest spot? Because this person knows everything that this person is doing, first of all. Okay, everything. Yes, everything, literally everything. Okay. And this person knows much more than this person, basically data analyst. Okay. But this person doesn't know everything that this data engineer knows. So this is a kind of bridge. This is a kind of role which is senior to data analyst, but junior to data engineer. Are you getting my point? Because see, data engineer is itself a kind of senior role. Yes, you can see some fresher roles for data engineering, but it is very less. But whenever someone wants to hire a junior data engineer, they were using the terms, let's say, junior data engineer, but nowadays they are using the terms, let's say, analytics engineer. Still, they use junior data engineer or data engineer with less years experience. I'm not denying that fact. I'm just simply demonstrating this particular profile, why you are seeing this profile even more in your job portals. Because this is a kind of profile that you can consider as a junior data engineer as well. So this person knows a lot of things, almost everything that a data analyst knows, but this person knows something about the work that this data engineer is doing. Not everything, just to clear the expectations, not everything, but some things. What some things? We're going to discuss about that. Obviously, that's why this is the masterclass. But I hope now you know who is this analytics engineer, why this is the sweetest spot. See, these kinds of things can be automated by AI. And what can be? Just open Microsoft Fabric, write one prompt, and your entire dashboard will be ready in just few minutes. These are already being automated. Obviously, the solutions are not optimized. It is just the beginning point, but this will be optimized as well within just 1 to 2 years. It's not a big deal. But the work that analytics engineer does cannot, or I can say, will be very hard to automate by AI, because this analytics engineer doesn't just build the reports. This analytics engineer doesn't just write SQL queries to retrieve the data, select asterisks from this database, group by, having, join, blah, 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 blah. No. This analytics engineer works with the data models, data warehouses. You can say your schemas, your lakehouses, all of these things. And do you know what? I have been like analyzing this particular field a lot, like data field, like what will be the future of it. Obviously, I am not an astrologer, but let me just tell you my insights. If you are working more closely on the infrastructure side, more on the architecture side, more on the ownership of the entire lakehouse side, you are less likely to be replaced by AI. If you are working on just Power BI, SQL, some simple pandas, you can say transformations, your favorite Excel, then you know what do I mean. Okay, so this is the trend that I can see clearly, crystal clear. So this analytics engineer performs these tasks. Obviously, we need someone who can take ownership of the reports. Obviously, we cannot say, hey, AI, just build the dashboard for me and maintain it for the eternity. Obviously, no. We need a person. But this person doesn't need to spend the entire month to build one dashboard. This person can now build the dashboard in, let's say, just half of the time, or let's say quarter of the time, let's say in just 1 week. And rest of the 3 weeks, this analytics engineer will focus on the infrastructure that this data engineer alone was doing. Now this person will be an ally for this data engineer as well. And whenever we just work with bigger organizations, there are so many stakeholders which just come with some silly errors, silly requirements that require data infrastructure level knowledge in order to answer and debug those things. Who will do that? That role is booming right now. That role is booming. Are you getting my point? And then when you become the analytics engineer, then if you want to go more deeper technically, you can become a data engineer. Full-fledged data engineer, works with big data, Apache Airflow, Kafka, Databricks, Snowflake, all of these technologies. But if you do not want to, you can still be analytics engineer and you can lead the team. You can lead the projects, and I'm not just talking about the management roles, not at all. Technical leads, senior leads, like technically. This is the analytics engineer role, and I hope now you have a crystal clear explanation or understanding of who is an analytics engineer. If that is clear, please do let me know in the comment section. I want to see like who actually understood this role, because when you understand the role, only then you should go towards that direction. And if this role is not for you, then obviously you should think about it, right? So one thing is clear, you need to upskill yourself, and that is it. But how much and what exactly you need to follow, I am here to guide you. Simple. So I thought of just putting this section in the very beginning so that you are crystal clear about the expectations from this role, from this domain, which is actually not a new domain. It's just like knowing much more than you actually know and doing much more than what currently you are doing, because those things can be done by AI as well. You can use AI to boost your productivity, and you can just use the rest of the time to work on the infrastructure side. And I think this is a very common sense that every data analyst, like someone who has like some knowledge, some experience, 1 to 2 to 3 years, 3 years of experience, the person would know that these tasks are not enough. Because see, in just 1 to 1.5 years, these tasks can feel like automated, like feel like you are just doing the redundant task again and again. You build one dashboard, okay, 2, okay, 3, 4, 5, 6, 7, 8, 9, 10, okay, bro, okay. But what after that? Now you need to take the ownership of those dashboards, and now you will do other things as well, some automations as well. Are you getting my point? Like what exactly I'm trying to just tell you? AI is there to help you. AI is there to boost your productivity, productivity if you are working with this stack, and is actually helping you to take ownership of the infrastructure. You have to start taking the ownership. I hope this is Clear. Very good. Huh. First section is done. Very good. So just do let me know in the comment section if this section was helpful. I have specially added this section. Who is an analytics engineer? Because see, you will go on LinkedIn and you will say analytics engineer. You will find actually a lot of roles, obviously, and you will start reading the JD, and you will say, what is this SCD? What is this ELT? What is this DBT? You will say, bro, what is this? So you need to know what is this thing. Okay. So now, because now we know who is an analytics engineer, now we need to start preparing, start learning for it, right? And the learning starts right from the data lifecycle. Data lifecycle. Okay. Now, what is data lifecycle? If you are a data engineer, you would know this thing for sure. Because see, analytics engineer role is for everyone who wants to walk on the path to become a data engineer, or now yes, we have a pre-step or basically pre-role as well, especially analytics engineer, obviously. So I still remember, like, when I was just starting my journey of my data engineering, I also went through this data life cycle, and I was like, oh, I actually didn't think about this thing like this. Like, obviously everyone knows about data life cycle. Data is generated, data is loaded, data is reported. Yes, this is true, but when you just dig deeper, you actually understand what this person and this person needs to do. We will focus on this person because we are talking about this person, okay? But because I said that this person needs to know a lot of things that this person is doing, right? So we will simply take this person as an example. Let's say this person's name is Rahul, okay? So we'll talk about Rahul from now onwards. Very good. And yeah, so if we just talk about data lifecycle, we need to know what exactly the data lifecycle, because I am assuming that you are in the data domain, you are working with data obviously in the organization, but let's say you actually do not know the entire data lifecycle. Might be because you are actually, let's say this Rahul was like, has started preparing for the analytics engineer role, obviously, okay, because it is his or her goal. Rahul is obviously a boy, let's say anyone, okay? So this Rahul was most probably working on something called as, let's say, warehouses, or let's say databases. Sometimes databases in small organizations, they do not build warehouses, they simply build databases, and they are happy with that. And nothing is wrong because it's their data, they are the owner, and they can do whatever they want. So this person was actually directly working with these two things and was building some reports, was building, let's say, some queries, SQL queries, was building some Panda scripts to perform some analysis and handing over that analysis to their managers or anyone, right? Everyone knows this thing. But do you know what? How data, forget about SQL database, how data actually reached till data warehouse? That is the thing that you now need to know, bro. Now you need to know how this data warehouse was created and how the complete data lifecycle actually moves, because you need to take care of that lifecycle as well. Yes. So let's try to see that lifecycle. Okay. So let's say everything starts with something called as data generation. Okay. Now be with me. Okay. This is a very in-depth section first of all. So it will be called as, let's say, data generation, because we are going to talk about data lifecycle. So just listen or basically take notes of these things, data generation and all of these things that I'm just going to tell you, because these need to be in your notes. Obviously I will provide this particular notes, but just create your own notes as well. So let's say data generation, which is the very first step of our lifecycle. We are working with data. How? Because we have data. We are building reports. How? We have data. We are building data models. We have data. We are building lakehouses because we have data. Because we have data. If we do not have data, we would not have done anything if we didn't get any kind of data, because we had data. Now, what can be the data sources? It can be literally anything. Let's say you are using your mobile phone. Do I have any mobile phone image? No. Very good. Let's say you are using your application, any application. You are using Amazon, you are using your favorite website, anything. Okay, you are doing some shopping, you are doing literally anything. Okay, let's say you are doing some shopping. shop, online shop. You are just scrolling something, you can literally do anything. Everything generates data. Literally everything generates data. Everything. Okay. So now when everything generates data, we need to obviously store it somewhere. Obviously, and in most of the cases, these data generation will be applications. It can be mobile application, it can be web application, it can be literally some IoT data, it can be anything. But most probably it will be coming from an application, a kind of interface. You are watching this video, this is also a kind of interface, right? You are watching this information, this is also a data. So we are actually getting the data from an interface, okay, and we need to simply store this data somewhere, like anywhere, okay. So that is why we start our data lifecycle. We simply say, hey, data is being generated, now we need to do something, how something, and what something. Let me just tell you. In most of the cases, because you will feel relatable, I want to mention this step. By the way, this is not mandatory in all of the solutions, but in some solutions. Whenever we talk about data generation, we sometimes refer to something called as associated SQL database. What does it mean? Let's say your organization has built a website. Okay, let's say you're working in a product-based company, and let's say, for example, Amazon. Now, Amazon has some sources for data. Their Amazon website, application. You are just simply selecting some products, you are simply liking some products, you are simply saving some products, you are simply buying some products. So everything, every click is being recorded, every click is being stored somewhere, where in most probably in case it will be stored in the database, most probably. So this thing needs to be there. This SQL database needs to be there because it needs to store your data. But what type of data? Transactional data. Okay, transactional data. Now, what do we mean by transactional data? Basically, transactional word is like self-explanatory. Transactional mean transactions. You are scrolling, transaction. You are buying something, transaction. You are doing any action, transaction. You need to record anything, transaction. Everything is a transaction. That's why we store the data immediately in the SQL database, in the transactional database, or you can say RDBMS, Relational Database Management System. That's why you see the databases like MySQL, PostgreSQL, Microsoft SQL Server, Oracle SQL. If you have some hosted applications, these are the databases which are very popular that we use at the starting point for our organization's data, because our organization's data is stored in a database. In some cases, it is directly coming from the application. What do I mean? Sometimes it is not, let's say, attached to your company's database. Let's say there is a kind of, you can say, application, a kind of web application, or any kind of API that you are using to pull the data. And in most probably, this will be like HR department data. So let's say you have some application for HR. Okay. And for HR, you have hired, or basically considered a kind of outsider, basically a kind of contractor, to save all the information for your HR department. And now that data is not directly synced to your organization's database. Not at all. Not at all. This particular, you can say, your HR department's application will be directly fetched in the form of APIs. That's why you hear that we work with APIs a lot. But do you know what? What are APIs? APIs are nothing, just a kind of middleman between you and the database. You and the database. So what will happen? Let's say I am this person. Let's say I am this person. Let's say Rahul. Or no, Rahul is this one. So let's say this person's name is, I don't know. So let's say this is the person. So this person will use this API to fetch some data, right? But do you know what? Whenever we say that I want to fetch the data from the API, there is a database, let's say Oracle database, any database. is actually attached to that API. API itself cannot generate any data. If that is a kind of pseudo API or toy API where you are generating the data directly in the form of JSON, that is a different case. But in most of the cases, there will be a database attached behind this API, and you will not have access directly to this database. So in this case, you simply make an API call to this particular API, and this API goes to this database, and this database returns back the data, and this API will return data to you. Okay, so in short, data is generated and stored immediately. So that is why, according to me, I should keep database, but which database? Relational or transactional database. Okay, at the point of data generation, because it immediately captures the data the moment it is generated. It is not running in the fly. It is there. It is attached. Okay, this is my personal, you can say, understanding of it. You might find it in some books, you might not find this in some books, but you will find it whenever you're just talking to Ansh Lamba. Okay, so this is data generation. Perfect. Data is generated. The moment data is generated, everything is good. But now, do you know what? After data generation, our real process starts. Here, till here, we are not involved. Yes, we are not involved. Then who is involved, Ansh Lamba? Because there I can see database, and whenever we talk about any data, we should involve any data professional, right? You are right. You are actually right. But still we are not involved. Why? Because we have a special data role which is not very popular in the data domain, because this role is actually a kind of senior role, first of all. Second, you will hardly see any openings for this kind of role if you are a fresher. Third thing, this role go hand in hand on the admin side. That is why this person, whoever handle this step, is actually considered as, let's say, DBA, database administrator. Okay, this is database administrator's task. In some organizations, if they do not have any database administrator, which is a very rare case, but still there can be chances. So what will happen? The senior software engineer or senior, you can say, developer who have built this kind of web applications for the organization, person will simply configure a database behind the scenes to store the data. In some organizations, they do this. They do this as well. But in most of the organizations, they will have DBA, because without DBA, it's not possible to manage and maintain their databases if they have very crucial data, right? So this role is actually called DBA, database administrator. Have you ever heard data analyst working as a DBA? In small organization, obviously they can, but usually they do not work as a DBA, because DBA is actually a different domain where you just need to learn about database design. You need to know about relational database design. You need to know about normalization, first normal form, second normal form, third normal form. Obviously you need to know these concepts if you are a data professional, but you use these concepts instead of implementing these. What do I mean? Let's say you need to know first normal form, second normal form, third normal form, and database design, primary keys, foreign keys, referencing tables, constraints, indexes, but you do not create SQL databases. You use SQL databases and you build data warehouses. That is the difference. You are a data professional, you need to know fundamentals, because whenever you are working with database, you need to understand it, because you still need to write SQL. Writing SQL is a different thing. Writing SQL for creating databases is a different thing. Both are different. Both are totally different. One is called DQL, data query language. Second is called DDL or DML. And data professionals do not touch these things here. You cannot directly write DDL, hey, drop table in production. You will not even have access to these databases, I'm so sure. Especially for some you will have, but not for all. You have to ask DBA, hey, please allow me to make some changes in database because it is required or something. Are you getting my point? So this role is called DBA. So we are not entered here. In some organization, yes, we have exceptions everywhere, but I'm just talking about normal generic organizations. Okay, because in startups, one person can literally do everything, obviously, but that person would need to know everything. But yeah, normal. I'm just talking about normal world. Okay, so now our role starts, but actually our role started here as well because database is there, but I just want to tell you that this will be maintained by DBA. It will be used by us. Okay, this point is clear. Maintained by DBA. We will not maintain it. We will use it. Okay, very good. Now, the very second step of data lifecycle is data extraction. Okay, data extraction. Let's talk about this thing. Have you ever heard about data fetching instead of data extraction? If yes, this is the same thing. Okay, data extraction. So when we have data generated, we need to extract this data as well. Simple. We need to extract this data as well. Now whenever we just extract this data, we simply need to just load everything that we have. Why? That is a kind of feature that we follow whenever we are just doing any kind of data extraction. Let's say I have this particular thing, RDBMS. I will simply say, hey, I want to extract my data. Simple. Simple. I want to extract my data. Okay. So here we will simply put our data in the as is form. Now, where do we put our data? In the modern world, we put our data in the data lake. Okay. Let's say it can be ADLS Gen 2, it can be S3. If you're using Snowflake, it would be Snowflake. But yeah, there are like so many options. Okay. So here we use data lake. Why? Data lakes are cheap. Data lakes are inexpensive. Data lakes are actually the go-to solution for the modern day data lifecycle. Okay, we simply extract this data. So whatever data is generated, we need to extract it. Simple. This doesn't need any kind of explanation. Very simple thing. We need to extract it. Very good. Once the data is extracted, then what we need to do? Then we need to transform this data. This is the actual thing that you need to understand. Data transformation. Now we need to transform this data, whatever data we have loaded, obviously, right? Whatever data we have loaded. Now what will happen? Now we simply need to say that, hey, whatever data that you have loaded, please transform it. What do I mean by transformation? Now, just to set the realistic approach, you would imagine that data transformation is about, or data engineering is about dealing with messy data sets. It's not actually the truth. Data engineering is not about handling messy data sets. Data engineering is all about building the entire system, entire data ecosystem. You would work on the projects where you will hardly see any kind of garbage in your data, and still you would spend 90% of the time building complex data workflows. Why? According to the requirements of the project. Maybe in that project, the requirement is just to build such a robust solution that it can automatically trigger the pipelines on failures. They can automatically detect what is happening. They can automatically detect the logs. They can automatically monitor the pipeline. They can automatically transfer the state of all of these things. I do not need to be very technical here, but I'm simply telling you the truth. Simple data sets can create complex pipelines, and reverse is also true. Even the messy data sets, literally messy data sets, the data sets where you will simply spend 90% of the time in just transforming the data, that will literally build just a very simple pipeline. So do not consider data engineering as just about dealing with messy data sets. That is not true. Okay, very good. So now whenever we want to transform our data, we have specialized frameworks. We cannot use our normal thing that we just use, let's say pandas and all. Why? Because we work with big data. Here the data that you have just stored is actually big. Just think about it. There is so much data being generated, and you have literally fetched or extracted everything. Now you need to transform it, right? So now in order to transform your data, you use frameworks, let's say Apache Spark, like this. Or you can also use frameworks, let's say DBT, we will talk about it, don't worry at all. And why do we use it, you will also know it. And let's say like this. And by the way, see, Spark and DBT are not like different tools. They go hand in hand. So do not feel like DBT is like a replacement for Apache Spark. But because I need to tell you the frameworks that we use, so I'm simply telling you. And do not consider these as tools. These are not tools. These are the infrastructure, bro. These are the entire framework in itself. Because whenever you need to run Apache Spark, it's not a simple thing. It's actually like managing an entire infrastructure. Okay, Apache Spark is there, DBT is there, and these are the two very famous frameworks, and both go hand in hand. Do not feel like one is the replacement for other. Not at all. Not at all. DBT alone cannot do anything. Nothing. So this is data transformation. Let's say you have transformed your data as well. Very good. Then once the data is transformed, then what? Then comes the real part. Every part is real, but this is the hero part. Data modeling. Once the data is transformed, now we need to create the data model. Make sense? Data model. Let's say we just want to create a data model. Now you need to know one thing which is very important for you. Now this is not just a kind of normal data model that you just saw here in RDBMS. This data model is different, and obviously we'll talk about it in detail as well. But for now, you can just imagine that this is a special kind of data model which uses facts and dimensions table. If you are coming from the reporting background, you would have worked with facts and dimension tables in your maybe Power BI semantic data set option as well. But creating facts and dimension table there is not equivalent to creating facts and dimension tables here on the server side. That is why whenever you work on the projects, we always ask this thing from the project owner, that hey, do you want us to create data models, or you want data analysts to build the facts and dimension tables? If the data size is low, if the data size is small, we simply say you can ask data analyst and they can build facts and dimension tables for you, because they can handle that load. But if the data size is big, if the complexity is huge, if they just want to handle concepts like SCDs and all of these things, then we simply say we will take the ownership, we will build facts and dimension tables for you, and data analyst can directly use it. So this is the question, that who will build it? And previously this was purely isolated, but now because we have analytics engineer role, now this data modeling part is the most crucial part that they need to take ownership of. And I hope it makes sense. So whatever things we have covered, let's say data generation, data extraction, data transformation, data modeling, everything is good. Now we simply say data storage. Now we also want to store this data anywhere, and we can create data storage like this. Let's say data storage is everywhere. Why everywhere? Because whenever we just want to extract in data, we will simply load this data somewhere, we will transform the data, then we will also stage that data. After data modeling, we will also store this data somewhere. So this is called data storage. Okay, simple. And now at the end we have reporting, data reporting, which is purely independent of any kind of storage, anything. Obviously in the latest features of Microsoft Fabric, they also work with one lake, which is a different story, but I'm just talking about a normal data reporting where anyone can use, let's say, traditional Power BI or Tableau. So this will be this particular thing. So let's say Power BI, and this will be Tableau. Do I have Tableau? No. So let's say just Power BI. So this is your entire data lifecycle that you just need to know. And I hope it makes sense. Now just look at it. Data generation, okay, and then after that we have data extraction, data transformation, data modeling, and storage everywhere, and then Power BI. Now I want to ask you one simple question, and I think now you will be able to answer this. If not, do not worry. I want to ask where the analytics engineer, where does the analytic engineer role fit? Simple. Dust. Now just tell me one thing. Where does the role fit? Where? So earlier, this entire thing, let's say right from till here, this was purely managed by data engineer. Obviously, that is true. This is still true. And this thing was actually managed by data analyst, right? Let's say this is data engineer, this is data analyst. Perfect. Now, analytics engineer, obviously data analytics engineer, analytics engineer role starts from in the middle of transformation, because person should know transformation, and it goes till here. This is the data analytics engineer. Let me just change the color. Let's say red. This is the analytics engineer. I hope it makes sense, and I hope it sets the your expectation. See, if I just zoom it. So now person needs to know how to store the data, transform the data modeling for sure. And you know what? I do not even need to tell you the importance of data modeling, because even if you are a data analyst right now, even if you are not a data analytics engineer, you still work a lot with data modeling in Power BI, and not just Power BI. I would assume that you still know the importance of having a good understanding of facts and dimension tables, surrogate keys, and all these things. So this is the thing that you need to know. This is your analytics engineer role, which fits in the middle of data engineer and data analyst. And you now know from the data lifecycle point of view as well. Now your expectation should be crystal clear, because I am not here to tell you like, hey, you just need to know this. Hey, you have to just know this tool. Not exactly. I can just give you all of the things. I have to tell you what this domain is about, and then you will have a crystal clear understanding like what exactly you need to learn, where you need to stress more. Maybe your data transformation is already good. You already know these things. You can just stress more on data modeling, or vice versa, or this thing. Simple. Makes sense. So this is the complete data lifecycle of analytics engineer role. So now I want to talk about a very important topic that any analytics engineer need to know. So now obviously we need to just talk about the topics as well, like what exactly you need to know and how you need to know. And now we need to talk about the real topics as well. Obviously this, do you know what? See, if you understood this entire data lifecycle, if you understood, I use the word understood, if you actually understood the meaning of this entire data lifecycle, you would actually work as a better data professional. I am so sure about it. Because when you know the entire data lifecycle, you can actually connect the dots. But if you are simply working on the reporting side, if you do not actually know how these things are happening, you cannot feel connected. Then those things came into the picture. Like AI is automating the things, AI is automating the reports. AI can automate the reports, but AI cannot automate the entire system. AI cannot automate the entire ecosystem. AI cannot automate the entire data lifecycle. It is next to impossible, bro. Next to impossible. And it's not just about like being possible or not possible. It's about we still need ownership on these things. We can use AI to boost the productivity, but we cannot just replace data professionals. We can reduce the number of professionals. Let's say in an organization, 10 people were working. Now maybe 2 or 3 or hardly 4. We can reduce the numbers, but we cannot replace. Reduce, yes. Replace, cannot. Simple. So now you need to be in those top 3 or top 4 people, so that you have right skill set, so that you can be that particular asset which is not replaceable. Just tell me one thing. Let's say you are the owner of the organization and you have 10 people working in the data team, and you just want to use 3 or 4 because now you know that you have Claude Code, now you have Copilot just to do all of the stuff quickly. You have 6 people who just knows how to build reports, okay, and who just know how to write SQL queries, and there are 3 people who know data modeling very well, data transformation very well, DBT, Spark, and they understand the data lifecycle very well. Forget about AI, forget about big companies, forget like stop blaming those big companies firing people. Just tell me about you. Will you keep those 6 people or will you keep those 3 people? Just tell me one thing. That I want to hear your thoughts. You will say those 3. Why? Because you are the owner, right? So this is like common sense. This is common sense. All about supply and demand. Earlier, supply was less, but now they do not need that kind of demand. Why? Because they know earlier 10 people were required to do a task. Now I just need 2 to 3. That's it. That's it. It's all about supply and demand. It was never about you know something and I do not know this thing. It was never about this thing. It was never about like learning this thing and not learning that thing. It was all about supply and demand, and that's it. And it will only about supply and demand. If now the demand is for learning AI, you have to learn AI. That then only your demand will be there in the market. I hope you get my point. Okay. And now let's talk about a very important concept for you, which is the key of today's data lifecycle. Not lifecycle, the entire thing that we do. It is called, first of all, ELTL. What is this thing, Ansh, Lamba? We have heard about ETL. We have heard about ELT. What is ELTL? It is not a kind of term that exists in the books, but this is a kind of term that we data engineers use on a daily basis. What do we mean? So earlier, when we didn't have much data available on the data generation side, on this side, and you know what, I will be referring to this diagram a lot of times now because everything is embedded within this. This is the beauty of this. So earlier, data generation side was less heavy. It was like very weak. Okay, like there was like hardly billions of records and that's it, and we didn't have like much data. Billions like means billions of records for the entire organization, and it's not a big number. Okay, so let's say what we were doing, we simply had, let's say, a kind of SQL database. Okay, simple, and we have some data, and we used to simply extract the data, right? Because this data lifecycle needs to be followed, right? Extract the data. So I'll simply say I want to extract this data, and I want to, let's say, extract it. Simple. So I'll simply say extract. Simple. Very good. Now, do you know what? When I extracted this data, I simply put the data nowhere. What do I mean? So I extracted the data, okay, and immediately I transform the data as well within the same query. Okay. So let's say transform. And after transforming the data, I then loaded it in the data warehouse, because earlier we used to work with only warehouses, okay, on-prem data engineering. And this is called ETL, standard ETL approach. Okay. And I hope you would have heard about this concept. ETL is a like very popular approach, very popular. We sometimes still use this word ETL, but this is not something that we do nowadays. So this is called ETL, standard approach. This was the heart of on-prem data engineering. Old school data engineering was purely based on this thing. That is why we had tools such as Pentaho data integration. There was one more very popular. Oh man, that was like so popular tool. It has like orangish logo. Pentaho data integration, Informatica. Okay, Informatica. So Informatica and Pentaho, these were like very popular ETL tools that people used to just integrate with their workflows, where you can just literally create these ETL pipelines that you can run recurrently. Okay, and this was a standard approach. And this was the approach when we didn't have data lakes, when we didn't have those data warehouses, cloud data warehouses, simple data SQL. So we used to even load the same data in the database. Yeah, obviously with different strategy, but the storage layer was same, database. Oh, really? Yeah. So yes, we were just building data warehouses in your MySQL database, PostgreSQL database, like this. Okay, so this was a you can say traditional approach, but data started growing. Data started growing. We were not able to literally transform the data with such a volume, and it's not like we were not able to, it was like wastage of resources, because we are simply extracting so much of data and then we are not loading it anywhere, and we are literally processing all of the data that we do not even want to. Then we have a concept, we got a concept called ELT. Okay, ELT or ELTL, both are same thing. I will just tell you why, and you will also say, Ansh, Lamba, you are right. Okay, so I always call it as ELTL. So now we have this data, obviously, but now the data size is like huge. I would say trillions of records will be like too much, but let's say 100 billion or let's say 200 billion, these much of records, 100 times more. Okay, now I will, yes, extract this data for sure, but after extracting the data, I will immediately load this data in a kind of storage layer, and this storage layer is nothing but your data lake. Why? Because data lakes are cheap. Okay, so I will attach data lake with extract stage. Wow. Then I will transform this data, and it will be very easy for me. Why? Because I just want to transform the data that I want, and it is already there in the data lake. I do not need to put pressure on this poor SQL database. Okay, so this is my transform, and this will also have data lake attached. Yes, and finally we will create a kind of load stage, like final load stage. You can say load, and this will be attached to the data lake as well. Yes, so this becomes my ELTL because I am extracting the data, I am loading it immediately. So EL, then I am transforming the data, and then I am loading the data again. It is not just ELT. After T we have to load it again. So that is why it is like ELTL. But just for the, like, you can say common terms, because we were using ETL, so we simply said ELT, just for the easy naming convention, that's it. But ideally it is ELTL. Okay, makes sense, because we need to load the data. So this is the same thing that we are doing in the modern data lifecycle. We have extraction, we have storage, we have transformation, we have storage, we have data modeling, we have storage underneath. Make sense? I hope so. So we cannot simply do the processing directly, you can say, while fetching the data. We have to put this data somewhere. There are tons of benefits of it. Why? Because this makes sure that you can reuse the data. You can create a staging layer, a kind of persistent staging layer. There are multiple layers of ETL and ELT. The very first is, I think, staging layer. Okay. And staging layer also has two types, persistent and transient. So this extract stage is actually a kind of staging layer. Okay. And this has two layers. Transient. Transient means your temporary layer where you do not store your data for the longer period. Maybe you will just revoke it in just 24 hours or maybe immediately after loading the data. It depends upon the design. And the second layer is called persistent. Yes, now analytics engineer needs to know these things. Okay, because obviously you will say, oh, we didn't know these things. So this is all about your let's say this color. Perfect. Persistent and transient. Simple. Very good. So these are the two things. This is the staging layer. In the transform layer, you can create a staging layer, but it doesn't make any sense because you are already creating a staging layer for the raw. Simple. Now the beauty of this ETL and ELT is whenever you perform extract, you simply extract the same data as it is without any kind of transformation. So you can actually compare the data between the source and the extract layer because you have literally stored the same data in the data lake. But here you were not able to do this. Obviously. Makes sense? So this is one thing. Then Why did we move to ELTL? Why? First reason is obviously data size, because now we are just dealing with big data and now we do not have like much resources to work with that big data, and now with AI data is even bigger. Now the major reason after data size was compute. Because data size is big, we need to put more compute to process that data, and not just process that data. We needed a solution where we can efficiently store this data somewhere. When we store this data in the SQL database, it is very expensive. It is very expensive to maintain those databases. Are you getting my point? So here comes the concept of data lake. Now, if I would ask you what is a data lake, according to you, you will simply say data lake is something where we simply store our data in any file format, which is actually true. In data lake, you can literally store this data in any format. But why did we and how did we introduce data lake? This particular point of discussion is very important. Now let's actually discuss it in detail. So let's try to understand the entire architecture of this. So first of all, data lake is not the direct thing that we got. Before data lake, or I can say the backbone of data lake is actually blob storage. What is this blob storage? Let me just tell you. Because if you understand blob storage, you can actually understand the data lake. Because data lake is not actually a kind of component. It's the architecture in itself, which is built on top of blob storage. So let's say you have one blob storage solution. It can be, let's say, S3 bucket. Let's bring it, which is a very popular one. Or let's say ADLS Gen 2. My Azure people will say, bro, bring ADLS. Okay, so let's say ADLS Gen 2. So let's say you have created one ADLS Gen 2 instance, which is a kind of Azure data lake solution in Azure. But forget about data lake. I do not know what is this thing, but I know there's a solution called ADLS. Simple. Okay, cool. So now let's say you have this particular solution. Perfect. Now you want to upload one file on the cloud. Simple. Let's say I have a file and let's say I want to upload, let's say this file. Let's say you uploaded this file. Now do you know what will happen? You see one file. And by the way, that is why we call it as like binary large object. Blob means binary large object. This will be considered as a large object. Okay. But behind the scenes, this file will be converted into small chunks. Wow. Yes, small chunks. Let's say 1, then 2, then 3. And each chunk will be distributed across the disks. Yes. Do I have disks? No. Let's say any kind of server. Do I have anything? Let's say the disk. So this is, let's say, disk 1. Let's say, for example. So this will be like disk 1, which will be attached to this particular chunk. And there will be another disk for another chunk. It can be same as well, but most probably it will be like different. So this way, Azure manages the blob storage. Binary large object will be converted into the form of chunks, and each chunk will be distributed among different disks. But Ansh, Lamba, when I just double click on this file, I simply see everything together. I do not see just one chunk or two chunks. That is why I am just saying that this is kind of a solution provided by Azure. That means whenever you open this particular file, double click on it, you will simply see the entire file, because Azure will reassemble all of these chunks that was shared across the disks. Automatically, everything by Azure. Wow. So this was a concept of blob storage, which is very similar to block storage. Now what is block storage? So whenever you do the same thing in your local machine, same thing happens, but in your OS, in your operating system. Let's say you have a file in a folder, right? Double click on it, you will see the entire file. But do you know what? The moment you store the file in the folder, that file will be converted into small blocks, BLOCK blocks. and then each block will be shared across different regions of your disk, the ROM that you have, read only memory, SSD, HDD, whatever laptop you are using, right? So each block will be distributed across multiple regions of your just one disk, because you just have one disk, right? And the moment you click on that file, it reassembles those blocks and just represent the result. And here in the Azure as well, they use the same concept. They simply distribute the chunks, but not on just one disk, across multiple disks, because they have like literally data centers, right? And the moment you double click on it, they simply see it. Now this is the backbone of it. Now they simply said, hey, we have a lot of data, as you can see here. So why can't we just create the data in the form of files so that we can store it here? Point is right. That's why data lake was built on top of blob storage. Now what is the difference between blob storage and data lake? Blob storage is just like storing your blobs, storing your large objects. But when you just want to create data lake for big data analytics, you simply need to enable something called as hierarchical naming spaces. What does it mean? For example, let's say you want to store your data in the dedicated folders, right? Let's say you are just creating an orders table. So what you will do, you will simply say, hey, I want to create one folder, and this folder should be named as, let's say, orders. Why? Because I'm creating an orders table. So I'll simply create this folder and I'll simply call it as orders. So all of the files related to orders table will be stored inside this particular folder. That's it. So this will be considered as my orders table. So this was the architecture of the data lake, and this is still the architecture. But we have actually entered into even more advanced era, because after data lake, we found amazing, you can say progress, or you can say amazing performance in terms of storage. Why? Storage means cost, from the cost perspective. Business leaders were happy because there was not much cost associated with the solution, but the performance, the quality of reports were degrading. Why? Because everyone knows that SQL actually provides amazing reporting capabilities, because it can run SQL. Structured query language actually gives us that particular thing, and it's not just about performance, it's about much more than that. For example, let's say I want to perform ACID transactions, or any kind of ACID property, let's say atomicity, anything. I can do it in SQL database, and I hope that you know ACID transactional properties, right? Atomicity, consistency, isolation, durability, right? I hope so. So if I want to perform those things, I can do it here, but I cannot perform ACID properties here, obviously, because these are the files. So when we started seeing these errors, then we got introduced to the concept called Data Lakehouse, which is the current most popular thing. And yes, now you, analytics engineer, needs to maintain plus build this as well. I'm so sure. So this is called Data Lakehouse. Now what is this thing, Data Lakehouse? So now we know that our data is stored in the form of, let's say, file, like in the form of data lake, in the data lake. Simple. Very good. Now I am happy with this particular thing from the cost perspective. Very good. But I am not happy with the performance, with the quality. So what I will do, I will simply say, I will combine the data lake for cost, and I will combine the data warehouse for the quality. Ansh, Lamba, you are cutting the cost, or you are increasing the cost, because data lake is already here. Now you're adding data warehouse. That is the power of Lakehouse. We add data warehouse for sure, but you know what? In a smarter way. What does it mean? Data lake is there for sure, but this data warehouse is not this traditional SQL database. No, not at all. Then what? We introduce something called as open table format. Okay, open table format. What is that? We will just talk about it, don't worry. For now, you can consider it as alternative to data warehouse, but it does everything that data warehouse needs to perform. Simple. Very good. Now what I will do, I will say I have the data, right? So what I can do, I can convert this particular data into Lakehouse. How? First of all, I need to consider or basically write my data in a specific format called Parquet, or my file should be in a specific format called Parquet. So I'll simply say Parquet. So let's say this is my file. Simple. Okay, perfect. So this is my file. Now along with this file, we need something else, because this is still data lake. This is not a kind of warehouse or anything. This is still like data lake. But now what you need to do, I will attach a kind of database. This database, this is a very special database and this is not your SQL database. So what is that? This is called transaction log. Okay, let me just draw it. So this is called transaction log. What is so special here? So let me just tell you. So let's say I have orders table. Okay, I have saved this data in the Parquet format. That is also clear. What is Parquet? Parquet is a special file format that we use for big data analytics, and it is basically a columnar file format that stores data column by column. For example, let's say you have some data in the table. You have order ID, you have let's say order number, you have price, all of these things. So it will not store the data row by row. It will store data column by column. So first of all, it will store your all the order IDs. Perfect. All the order IDs. Then it will store all of the order numbers like this. Then it will store all of the order quantities, whatever. Okay, like this. So this is called columnar file format. This stores data column by column instead of row by row. Makes sense? In traditional file format like CSV and all these row based file formats, you simply store data row by row. You say order ID, number, quantity, then order ID, number, quantity, order ID, number, quantity. But here we simply put exact entire column in just one go. Why? Because in big data analytics, we query more on the column side rather than just simply applying conditions while fetching the data. Okay, makes sense. So this Parquet file is there. Along with that, I will create this special folder which is also called as called as transaction log. Okay, transaction log. What is so special about this thing? Transaction log. This transaction log will take care of all of the things. What are the things? All of the transactions, everything. It will keep you can say track like this. Let's say log1.json, log2.json, log3.json. Wow, it will store everything like this. Simple. Everything like this. Makes sense. Okay, so this will be inside this folder. Now if anyone tries to query this particular folder, this orders folder which is stored in the data lake. Okay, now let's say this person wants to query this folder. Okay, simple. This person wants to query this folder. Okay, now when this person will be querying this folder, this person will receive amazing results. Amazing. Why? Because now this person can actually perform everything that he was performing with the SQL data warehouse. First of all, you can say processing, because obviously processing will be taken care by the SQL engine that we use, which is Apache Spark under the hood. But it's not just that. This person will be able to perform all of the asset transactional properties as well. Everything is possible. Everything. Because let's say this person wants to delete some data in this particular folder. This person can literally do this thing. Let's say select or not select delete from orders, where let's say order ID equals to 1. This person can do it. Yes, this is allowed. How? Because of this particular transaction log. because this kind of transaction log. Okay, and Ansh, Lamba, how this person is able to write these SQL queries if there's no SQL engine? That is because of Spark engine. That is because of Spark engine, because whenever we just talk about Spark, it has two things, PySpark and Spark SQL. So whenever we run anything, it goes to Spark SQL engine. So it can run your SQL queries as well. Make sense? But that is not a very big thing, because that was we were able to write SQL queries here as well in the data lake architecture. The main thing was changing these things like we do in the SQL data warehouse. Deleting the data, committing and rollback, all of these things are possible with this particular data lakehouse. Everything. That is why you are seeing it booming. Why? Data storage is cheap. You are literally storing everything in the data lake, and you can still get the same results that you get with the normal SQL database. And just tell me one thing, if you are a data analyst, if you are working with, let's say, or if you, let's say you are completely a beginner and you want to come in the data engineering side, you are still building reports. You are still writing SQL queries over data warehouses like Azure, Synapse Analytics, maybe AWS Redshift, Snowflake, Databricks. All of these things are lake houses. All of these things are lake houses, actually lake houses. Data, except Snowflake, obviously. The data is actually sitting in the data lake. But did you feel anything? You are literally writing the same SQL queries, right? That is the power of Lakehouse. That is the power of Lakehouse. You actually get the same results. Wow. That is why Lakehouse is booming. And you need to know how to build these things. How to work with data lake, Lakehouse. What is like that particular thing which enables transaction log? What are these things? Now, let me just tell you. Whenever you want to build Lakehouse, whenever, okay, and obviously now you always go with open table format. Okay, what is this open table format? Open table format is that particular, you can say, secret with the help of which you can run literally your SQL queries on top of these file formats. Or not just file formats, like not just running SQL queries, you can literally perform these things like ACID, transactional properties, and all of these things. What is this open table format? Open table format is basically a kind of abstraction layer. So what will happen? Let's say this is your folder, okay? And this particular open table format will simply add this transaction log along with your Parquet file, and it will create a kind of abstraction layer on top of it. Let's say like this. Now, if anyone tries to query this particular orders table, this will become your SQL data warehouse, but actually it is Lakehouse using open table format. This is the kind of abstraction layer. So let's say abstraction layer. By the way, the secret or the main layer is this one, which is your transaction log. That is the main thing, because once you have transaction log, you can literally do anything. Because you can still use SQL commands over data lake using any kind of abstraction layer, but this open table format, this enables this kind of, you can say, ACID properties for your SQL data warehouse. Simple. So now whenever we just talk about the open table format, there are two big players in the market, and I would say there are three, but two are more popular. The first one is Delta Lake, which is the most popular and the most mature one that we have, which is very popular with Azure, Databricks, Fabric, and the second one is Iceberg, which is more popular with AWS. There is one more, it is called Apache Hudi, but these two are like big players. So now the thing is, if you want to actually see this open table format in practice, you have to just do some hands-on with either of these two open table formats. I would recommend you to go with Delta Lake because Delta Lake is actually the most mature one and widely adopted in the industry. Iceberg is also very popular, but not as compared to Delta Lake. So I also want to give you a quick demo, very short demo, like how we can actually use one of these open table formats. And I want to pick Delta Lake for this thing. And to be honest, Delta Lake obviously is used with Apache Spark more when we just work with big data, but you can even work with Delta Lake using your normal Python pandas library as well. Yes, Delta Lake is even compatible with your pandas as well. So that is why I just want to show you a quick demo. And for this demo, I would need just two things. First thing first is you should have Python installed in your system. That is a very common thing. And second thing is any kind of code editor, VS Code, anti-gravity, whatever. If you have these two things, then you can just perform this particular demo, and we will be just performing this demo right now, and it will just hardly take 5-10 minutes. You will have one quick understanding how this log is generated, how this Parquet file is generated, and all of these things. Simple. Let's do it. So I have opened my VS Code editor. You can also open your favorite code editor, anti-gravity, cursor, agentic code editor. This is also agentic, bro. You just need to tweak something and this will also become agentic. VS Code, yeah. So now I have opened one empty folder first of all, and here we will simply go to our terminal, and here what I will do, and I also want to show you the official documentation. Let me just open that just in case, so that you would get the real resources as well. Let me just show you Delta Lake Ansh Lamba. Delta Lake documentation. Okay, so official documentation is this one. See, welcome to Delta Lake documentation. To be honest open source projects, especially in the data domain, do not have very well documentations. Like they have not very well documented everything, but Delta Lake is actually amazing. So we have Apache Spark connector. If you just want to learn Delta Lake in integration with Apache Spark, which is the most common use case, you should go with this one. And if you just want to use it with pandas, then I'm just showing you here as well. Do not need to worry, but this is the most common one. Simple. Using it with Trino, Starburst, Presto, these are also good, but in the industry, Apache Spark is the best one right now. So let me just find the pandas one, Delta standalone, Apache Flink, Apache Spark connector, or I can directly search Delta Lake resources contribute. Let me just search directly Delta Lake pandas. Okay, how to create and append. I think they have, so they have not added this thing into their documentation, but I think this is a kind of official blog that they have written. So see, it is very simple. You first of all need to use your normal pandas that you just use on a daily basis, and then you simply need to import Delta Lake from the Delta Lake package. We have this Python package available. Okay, you first need to download it, and then you will be able to use from Delta Lake and then import Delta table, and you can literally write anything that you want to. Let's actually try. Let's actually see what we can just do with it. Obviously, one thing to note, you will not get all of the features within pandas like schema evolution, upserts, all of these things, but you simply get very basic functionality with pandas. Why do we use pandas? We hardly use pandas with Delta Lake. I'm just simply showing you that you can even get started with it. So let me just first of all create Python virtual environment quickly. So you can also create it in your case. So I'll simply say .vnv. So why do we need to create virtual environment? Because it is important. I do not need to download it in my global environment. I will simply download this package in my virtual environment. Simple. So I'll simply say pip install Delta Lake. So this will download the package for me. Hope so. Now it is downloading. Yes, it is of 44 MB, 62 MB as well. Wow, this is big. And I have new version of pip available. I will simply update it. Yes, very good. I have pip 26.0.1. Wow. So I have my Delta Lake available. I can just check my virtual environment. I can go to libraries. I can see site packages. What? Oh, I just installed the package in my global environment. I'm so sure because I didn't activate the environment. So whenever you create the environment, you should also activate it like .vnv scripts and activate. Let me just show you .vnv and then scripts and then activate. Sorry, deactivate. What is not recognized the name of this thing? Scripts activate. Oh, spelling is wrong. Perfect. scripts activate. I think something is wrong with the virtual environment. Let me just reinstall it. So let me just say delete, and I think I saw one error as well. Let me just run the command again. Python -m vnv.vnv. This command is like old style. I use uv nowadays. Uv is a better approach, but yeah, just go with it. So now it is done. Now let me just activate the environment. Scripts activate. Now it is activated. I can see green sign. Very good. Now I can say pip install Delta Lake, and it has started downloading it. Perfect. I can just confirm libraries. Yes, I can see Delta Lake package here. Very good. So this is the package that I have got. Now let's say I just want to write some simple code to convert my data frame, pandas data frame, into your delta format, basically delta data format. So let's quickly copy the same code just to save some time. Quickly import pandas. So let me just install pandas as well. So I will say quick install pandas. Very good, very good. So now I will say, let me just do copy. They don't have copy button. Wow, very good documentation. So let me create one Python file. Let me say demo.py, and let me just write it here. And what do we have else? So okay, just a wrapper. Okay, good. Because they are not doing anything fancy, so I will also not do anything fancy. You can literally write any pandas code if you just want to, and I can move my imports in the beginning just to make it better. Very good. So what we are doing, I can simply explain you. First of all, I have a package called Delta Lake that I have just installed. Within that, this is the key, Delta table. Why? Because whenever I just want to write anything, I can just use Delta table as well. And within that, I have Delta Lake.writer. This is a kind of module, or you can say your utility that you use to write any data if you want to. So here, if I just want to write this data frame here locally, I will simply pass the location. So I can literally say data, because I just want to create a data folder here. Perfect. And that's it. That is it. Yes, I can simply run this file from here. Let's see if it creates that thing. Let's wait for a bit and let's see. Tutorial demo.py. Okay. Let's wait. What? PyArrow failed. Oh, I think it needs one more package, PyArrow. You know what? That's what I hate about pip. It does not install the dependent libraries. I have to just do it manually. But UV installs the dependent libraries as well. It's actually good. Let's download the PyArrow, which is another thing to convert your data to. Let's run this now. It should run fine now. PyArrow is also there. Let's wait. Okay, I can see data folder, and if I just open this thing, let me zoom, I will see perfect one file with Parquet format C dot Parquet. Okay, and do not worry, this is a naming convention that you will obviously see whenever you're working in big data, because we do not define any file name, because we only worry about the folder name, because we simply query this data like this. Wow. And this is a delta log which is automatically created because I wrote my data in the delta format. And if I just expand it, I will see this JSON. This is what? This is a kind of log. So in the log, I have all the things. Timestamp, when it was created, what command I have run, write operation, then reader version 1, metadata, add. Now, obviously, these are the technical stuff that you will learn in the Delta Lake course whenever you will be just watching it. And in that course, I have literally explained everything. I've literally, not just explained, I have literally mentioned how to, you can say, utilize these things just to do travel back, or just to, let's say, perform schema evolution and all of these things. But the intent is completed. We just wanted to see how we can just get started with Delta Lake right away. And this is the way. And if you just want to do more things, you can literally read this particular thing. And now let's complete this step as well. Let's say you have created one folder, delta folder. Let's say now you just want to read the data. Obviously, then you can use the delta table utility that we have just imported. Let me just create that as well. So now let's try to read this data which is stored here. So I'll simply comment it out because I don't want to write this data anymore. I'll simply say delta table and then the location of my data, which is data, and then dot to pandas, and it will simply display the data to me. Let's see the data in the console if it works fine. So initially it can take a little bit longer, obviously, but when you just run 2 to 3 commands, it will be running fine. Not a big deal. So I think I didn't set print. We are not running this in notebook, so obviously we have to say print. So now I can see my data. Wow. So this way you can literally replace your traditional SQL database. By the way, you should not replace your SQL database for these kind of small stuff, but yes, we literally replace the database completely with this open table format when we have big data, when we work with Spark. Because when we work with Spark, we get all of the utilities when we perform absurd and more statements and everything. But with pandas, we just have like very basic functionalities. Is it clear? Is the concept of open table format, which was such a big jargon for you, is it clear? Is it clear? If yes, then please do let me know in the comment section and tell that open table format is clear and we have learned till open table format. Good, very well done. So now I want to talk about a very important concept, and I think you would have heard about it. It is so popular, and in the big data it is non-negotiable, but I want to talk about it and then I want to show you the modern approach, because we do not follow the old ways approach. Let's talk about it. Let me talk and let's see what I will talk, because I also do not know. So let's say incremental load. So I am just going to talk about incremental load. What is this incremental load? If you are in the data engineering side a little bit, very little bit, you would know about this thing. If you are just a beginner, do not worry. Let me just explain this thing, because this is that concept which can actually hook you in the interview especially. And do not worry, I'm not just talking about interviews. I am like, my goal is not just to make you interview ready. My goal is to make you interview ready. Yes, on top of it, make you industry ready. Are you getting my point? No? Very good. So let's say you just want to perform incremental load, and why we need to perform incremental load. Why? For example, and let's actually understand this concept like this. For example, let's say I have the source, right? Which source? This same source, this same data lifecycle. This is the lifecycle that is like source of truth everywhere. Okay. So let's say we want to start extracting our data. Perfect. Now, if you remember, we considered that the size of our data is very, very big, right? So in that scenario, we would have, let's say, terabytes of data. Still, terabytes of data is like normal nowadays, but still, let's say you have terabytes of data, and bro, terabytes of data is not a small thing. Terabytes of data, 1 terabyte of data would have at least 1 billion would have 10 gigs. Approximately 100 billion records easily in 1 terabyte of data. I think so, maybe even more. So can you imagine the data size? So let's say you have such a big data size, right? So let's say this is our data source and we are working with this thing. And the very first step of our life cycle is data extraction. We know that, right? Now, do you know what? Let's say in your company, in your industry, you are, or not you, like anyone who is storing this data is, let's say, storing the data till like since 2000 till 2000 obviously now, okay, 2000 till now. What is now? Today is, let's say, let's take any random date, 2026, like 1st of January, let's say. Okay, like this time it's April, but let's say January. Okay, just for the easy example. So here we have data from 2001 till 2026 Let's say today is 1st of January 2026. Perfect. Now you got the requirement that, hey, you want to build a project, you want to just create a lakehouse, and you have this particular data source. You will say, okay. So the very first thing that you will do to load this much of data, which is obviously such a big task, you perform something called as lift and shift. This is a very popular term, lift and shift. especially in the Azure world. They even have like lift and shift services. Lift and shift. So here you will not perform lift and shift on your own. By the way, you can do it because we have Apache Spark, big clusters. You can do it, but sometimes any vendor would also support you. Let's say you are a big client of Microsoft, so Microsoft would help your organization. It can. I'm not guaranteeing, okay? It can. But let's say you are doing this thing on your own, right? In that scenario, you can literally create lift and shift just like one time load. It is called initial load. What is the name of it? Initial load. Simple. Initial load. And you will prepare a data warehouse. Let's say Lakehouse. Do we have Lakehouse? Yeah, we have Lakehouse. Here is the Lakehouse. Perfect. So let's say we created our Lakehouse. Simple. Very good. Now let's say this task is done. Obviously this task took much more time because this was the initial load. But now let's say today is 2nd of January 2026. Okay, so this database received new transaction for today, like new transactions or new data, and the data is starting from 26 0101 till 002. So this is the new data. Okay, now tell me one thing. When I will be performing the extraction step, okay, extraction step, do I need to load this data again? Do I need to load this data? Does that make any sense? Does that make any sense? No, I cannot. First of all, it is too heavy. Second, cost. Your manager will literally shout, hey bro, I just want to talk to you one-on-one. Obviously, because such a high cost is associated with this kind of task. You would do that if you had got lesser data, right? But that's not the case. Data size is such a large number, right? So what you can do, now you need to perform incremental load. So first you will first of all lift and shift this data. This data is there. Very good. Green. Perfect. Now you will only load this data, only and only this data, and you will simply like you can say copy this data like this, only this data, and let's make it green. That's it. Are you getting my point? Let's say now you have a new data for 3rd day. Now again, you will perform what? Same stuff. Incremental load. You will only load this data incrementally. That's it. Ansh, Lamba, do you know what? I understood this thing. But now tell me how we can just do this thing. We understood that incremental loading is important. Concept is very simple. But do you know what? Implementation is the main thing here. Now, let me just tell you the modern approach. How do we maintain incremental load? Earlier, we used to work with watermark tables, SQL tables. That is not the approach we follow right now in the modern industry. We follow, you can say, configuration file. Let me just tell you first of all. So what will happen? Let me just tell you the design. Okay. So here, what will happen? Let's say no data is loaded. Let me just remove all of these, and let's say no new data is also here. Let me just hide it. Perfect. This is the new data. Very good. Now, while loading this data into the lakehouse, or let's say while performing the extraction layer, I will involve one JSON file, a kind of configuration file. Let's say JSON, not a JavaScript, JSON. Okay. Perfect. So this is my JSON file. So what I will do, I will literally create this file on my loading stage, like basically in the data warehousing side, like the side that I control. Okay, so this will be in my control. I will create a timestamp here, let's say last load, or let's say last load, like this. Okay, last load. Perfect. Currently for the initial time, this will be, let's say, null. This will be, let's say, a kind of very small date. Let's say last load equals to 1900/0101. Let's say very small date, very small. So now what will happen? I will simply run my query like this. Select asterisk from orders, okay, where updated at, let's say we have one updated at column which displays this date, right? Updated at greater than equals to which date? This date, last load. Wow, yes, this is a variable. This is called dynamic SQL that we write. Simple, very good. Now because we have this particular variable, this will be changing every time. Simple, makes sense. So now what will happen? For the first time, this will load all the data, because obviously 2000 is bigger than 1900. Common sense. Common sense. And I do not expect any data before 1900. If there's some data, I don't know from where did you get it. If you get it, simply say 1800, simply say 1000. Very small date, because you need to make sure that your all of the data travels. Simple. Now this data is here, loaded. Now after loading this data, you simply need to add one task in your pipeline, wherever you are just performing anything. So you will simply say update this date to the latest date. So now this date will become 2026-0101. Very good. Now I have received new data. Let me insert it. Let's say this is inserted. Now I will run the same query, ditto same query, but this time only this data will be loaded. Why? Because now the last load variable value is this one. Wow, this is a modern approach. Earlier we used to store these kinds of key value pairs in the watermark table, and we were just maintaining that table differently. That was like kind of different headache. But now we simply create a JSON file and we keep it in the data lake, and that's it. In my control. Okay, developers control. Okay, so now this data will be loaded like this. Perfect. Then do not forget to update it. So now this date will become 01 and 02. Now let's say new data is here. Let's say like this. Now tell me one thing. What will happen? What will happen? It will simply load this data. Wow. And it will update this date. Boom. This is incremental loading with modern framework, with, you can say, file approach instead of those watermark tables. I don't know who manages that watermark tables. So this is the modern approach. Now what will happen next day? If let's say I receive new data, I will simply load the new data, and that's it. Very well done, Ansh, Lamba. Clapping. So this is incremental load. Now some of you will say, bro, this is simple incremental load and we are pro data engineers. Just tell us about backfilling. I know some of you can say this thing. Okay. So let's say backfilling. Now obviously beginners will say, hey, what is backfilling? Very simple thing, just an application of incremental load. Let me just use, let's say, yellow color. So let's talk about backfilling. Backfilling. So now what will happen? Let me just tell you the real world scenario where this backfilling appears. For example, just imagine that when we loaded some data after 2026-0102, that means this data, we got some corrupted records, we got some missing values, we got something that is not actually good. Maybe pipeline failed in the middle. We just need to reload this data. Okay. How can we just reload this data again? Because now the variable is also this thing. If I run my query with this thing, okay, what will happen? No data will be loaded because there's no data after 3rd of January, right? Common sense. But still, I want to load this data again. How can I just do this thing? Here comes the concept of backfilling. That means I want to backfill my data. I want to simply backfill my data. Here, what is a solution that you can think right now? You will simply say, Ansh, Lamba, why are you just worrying a lot? Simply say second and problem solved. Ideally, you are smart, but we do not touch this file because this file is our regularly running file. We should not touch this file. We should not. I know this is a like quick fix, but we never touch it, especially in production. So what will happen in that scenario? This is actually a kind of big topic in itself, but I want to pass this knowledge to you. Okay, I want to share this knowledge with you. So what will happen here, while creating my pipeline, I have to create a dynamic SQL query, okay, which will create a parameter. Let's say this is your entire pipeline. Okay, let me just move it here. Perfect. And now what will happen, or let's keep it here and let's copy this here. Let's say this is our exact pipeline. Okay, this exact pipeline will be here, and this time this entire pipeline will be using a special parameter. What parameter? Because we just create some parent parameters which are only accessible at the pipeline level. So I'll simply say incremental flag. Okay, and by default I will simply say 1, that means true. Okay, or let's say initial flag, like same thing, initial flag equals to 0. Okay, what is this flag? So when I run this query, I run it for initial flag equals to 0. Okay, that means I am not performing any kind of initial load, or I am not performing any kind of backfilling. You can also say backfill flag, because it all depends upon the developer who is developing it. I prefer initial flag. You can say backfill. Okay, backfill flag, you will simply say 0. The moment this value is 0, this pipeline will be running with this query. But when I change this value to 1 during the runtime, during creating the instance of this pipeline, during running this pipeline, if I say 1, then I can change this last load value as well in the same parameter. Are you getting my point? Because my backfill flag is 1, that means I want to perform the same pipeline. I want to run my same pipeline but with different parameter. So this is a kind of pipeline that we create in order to apply both the things, incremental load plus backfilling. This is a kind of production grade pipeline. And do you know what? If you understood this entire architecture of the pipeline, creating the pipeline is like so easy for you. So easy for you. So easy for you. And by the way, now you will ask, Ansh, Lamba, what tool, technology, what framework do we use to create these kinds of pipelines? Very good question. By the way, I want to touch on that topic later on in the orchestration section. But if you ask this question, let me just answer this question. If you are coming from the Azure background, or if you have interest to go towards Azure background or Fabric, because if you are coming from Power BI, or let's say if you are totally a beginner, if you want to come to data engineering, Azure is a good choice, because Azure is actually the best among data platforms. So you can simply go with Azure Data Factory or Fabric Data Factory. I will talk about it in the orchestration section, but because you asked, I am simply giving you the answer. Azure Data Factory and Fabric Data Factory. Now, you actually need to spend some time to learn the technology, because it is not just a simple tool. It is a frame. I told you, data engineering tools are not just tools that you think. Data engineering tools are the infrastructures in itself. Are you getting my point? If I say data engineering tool, you will say, there will be a simple tool, you will simply learn it. It is an infrastructure, bro. Infrastructure. Do you know what is infrastructure? Infrastructure means like complete ecosystem. So you can learn Azure Data Factory, Fabric Data Factory. Simple. I will just talk about this in the orchestration section. Okay, so simply remind this step. Perfect. Very good. So we create these kinds of pipeline, and I have created enough tutorials to create these kind of pipeline. Do not worry. I will just tell you the resources as well in the orchestration section. Just wait. Hold your feelings. Simply try to understand everything first of all. I know now you are learning new things, so you have that particular hunger in you. I want to learn. That's why this video, this masterclass is for you. Don't worry at all. Are you comfortable with this thing? Backfilling. Now you know what we need to do. Very good. Very, very, very well done. Now let's talk about a very important. Ansh, Lamba, your every concept is very important. Yeah, obviously. So now I want to talk about upsert. What is this upsert? Is it update or insert? Both. So upsert means update plus insert. Wow. What is this? We are hearing this word for the first time. Upsert. So now let me just tell you, why do we use this thing? And upsert is a non-negotiable. If you are coming from a strong SQL background, Have you worked with merge statement? This is exactly the same. If you are coming from a strong SQL background, because merge statement is actually this thing. Okay. If you do not know about merge statement in SQL, if you do not know about absurd, let's discuss about that. For example, let's say let's take this example. Let's take this example because this is like very simple example and it makes sense. So let's say we are simply loading our data from SQL to Lakehouse. Simple. Very good. Now let's say in the SQL table, in the SQL database, I have some records like this. Let's say ID and let's say I have age, right? ID is 1, age is let's say 20, ID is 2 and age is let's say 30, ID is 3, age is let's say 40. This is the data. Okay, and I loaded this data here. Perfect, cool, simple. Then next day I got new data. Okay, and now this time I got the data like 1 and this age is changed to let's say 25. Okay, in one day. Yeah, so let's say second, not second, let's say 4. Okay, and the age is let's say 27 and let's say 5 and 30. Okay, this is day 1. Okay, day 1 and this is day 2. Now I already have this data in my Lakehouse. Now if I simply ingest this data in my Lakehouse, what will happen? Ansh Lamba, it will simply write this data like this 1 2 3 and it will simply say 1 and then 25 and then 4 and then 27 and then 5 and then 30. Yes, but why I am seeing duplicates 1 2 times? Why? Now which value I should use? 20 or 25? Which value should I use? Oh, okay. That's where we need to perform upsert. Upsert means the logic is simple. Upsert means update plus insert. If I have any existing value, okay, if I have any existing key column means the column that we are comparing, because here we are comparing ID with ID. So if I have the existing value for the key column, it will simply update that value with the latest value, because this is the latest value 25. Very good. If I have new records like let's say 4 and 5, because these are not here, then it will insert the records. That is the concept of upsert. So let's say 4 and here it will be 30 and here 5, 30 and 27. Perfect, and this will be changed to 25. This is upsert. Okay, this is upsert. Wow. Yeah, how do we perform upsert? In order to work with upsert, you have two options. You can either use let's say Spark SQL. Yes, Spark SQL, because we can leverage merge statement, right? We can leverage merge statement. So we have two options. Let's draw it. So first is Spark SQL. Because of merge statement, we can leverage merge statement. Second option is Delta Lake. Yes, we can use Delta Lake as well, because with Delta Lake we have a special feature called Delta Lake table that we can just use to create an object within the Delta Lake, and with the help of which we can just create the merge statement, or basically upsert statement. Okay, so this is a kind of merge version of PySpark. And again, these kinds of things, whenever I just refer anything within the Delta Lake, that means that thing is already covered in the course. I'm so sure, because when I created that course, I think I created that course last year, I covered everything in that course. Okay, so if you have that particular curiosity that you want to learn Delta Lake, which is non-negotiable, you should just go with it. So Spark SQL and Delta Lake, these are the two options that you have if you just want to perform upsert on your data. And upsert is a thing that you cannot ignore, because you cannot have duplicates in your data. You cannot have. Simple. Okay, very good. Now I hope incremental load and upsert makes sense now. I hope so. Now, because I used a word called PySpark, I used it right now, right? Spark SQL. Ansh, Lamba, do you know what? I have also heard about these terms a lot, and I was still thinking like whether should I learn. I started learning it, but I was able to write some basic code, but I actually didn't understand the technology. Can you please tell us about this technology as well? And where does this technology fit? And what exactly we need to learn in this thing? And what analytics engineer will do with this technology? Very good question. Very good question. Let's talk about it. So now we are going to talk about Apache Spark and PySpark. And PySpark. Ansh, Lamba, first of all, tell us the difference between two. Very good. Because see, whenever you are learning something new, it's fine. It's fine. You are not supposed to know everything on day one, right? So there are so many things that you will be learning with your journey. That is called a journey. So do not worry at all. Just feel happy that, okay, you do not know this thing. Now, Ansh Lamba is there. He's teaching us simple Apache Spark and PySpark. First of all, Apache Spark is the framework, is the entire framework. PySpark is just the Python library with which we use Apache Spark or we work with Apache Spark. Oh, so just consider it like this. Let's say Apache Spark. This is Apache Spark. Okay. Apache Spark. So this is Apache Spark, and I want to work with Apache Spark. I want to leverage its power. I will just tell you about the power as well. I just want to leverage its capabilities, how I can just do this. Let's say, where is our Rahul? So this is our Rahul. So let's say he wants to use this Apache Spark, but he cannot directly work with it. This is just a, you can say, code written in Java. Okay. And not about Java. If you are just using any modules, you have to just use one interface between your package and your code, right? So that is why we have a special Python library available for Apache Spark, which is called PySpark. Wow. Okay. So you use Python to work with this particular Apache Spark. Okay. Makes sense. Simple. This is the way. Why did they create Python library? To attract all of the Python developers, because obviously Python is the most popular language in the data domain, and because they wanted all the Python developers to use Apache Spark, so they thought of creating a Python wrapper on top of their native Java code that they just used, because obviously Apache Spark is like written in Java, so you can use Java directly. You would have seen in the initial days of big data, people were like so much in demand who knew Java. Still they are in demand, but Python is Python. Okay, Java is Java. And you would also see this difference like between PySpark and Scala. So in the initial days of Apache Spark, I still remember like PySpark was popular, but Scala was even more popular, and people used to respect a lot of developers who knew Scala. I don't know due to any reason, because in those days Apache Spark was not actually optimized natively, but after that they just built amazing engines, AQE, added more and more optimizations. Then there was no difference between using PySpark and Scala, so everyone was using PySpark, obviously. And Scala developers were like, oh man, golden days are over. so Python is the best. So let's say this is our architecture, but now the question is, why do we need to use Apache Spark? What is so special here? And why do we why should we just use PySpark over pandas? What is special in that? So the thing is, Apache Spark leverages distributed computing. Now let's talk about this topic. There are two ways to work with any kind of, you can say, requirement. One is monolithic approach. Or you can say this is monolithic and this is distributed. Simple. Okay, what is the difference? Let me tell you. So monolithic and distributed. So first of all, let's talk about monolithic. Let's say you want to process some data, okay? And if you are just processing some data, let's say you have only one system. Let's say, where's the machine? Oh, where's the machine? I have one machine, wait, PC maybe. Bro, yeah, I have one computer. So let's say you have just this machine, okay? Very good. I have one more. Yeah, this is nice. Yeah, this is also nice. Let's use this one. So let's say you have just this machine, maybe the same one on which you are just watching this video. So now I ask you to process some data. Okay, let's say there's a big data in the Delta Lake, and such a big data, let's say in the warehouse. Wow, simple. So you will be processing this data. Okay, makes sense. Or let's say any file, anything. Otherwise you will be confused. Let's say any file, let's say this file. Okay, so you have some data, any data. You need to process it. Can you do it? Yes, I can do it. Very good. Because actually you can do it. But now let me just ask you one thing, that the size of this data is so big. Can you still do it? Yes, but I would need more resources. Very good. I wanted to listen this thing. Now you said I can do it, but I would need more resources, right? Very good. Now let's say I provide you the resources as well. Now can you do this? Yes. Very good. Now I increase the data more. Let's say double. Then what will happen? I need resources. I need resources. I need resources. That will be the only thing you will say, right? So for that, I have to keep on increasing your machine's resources if I want you to process more and more and more data. Wow, which is a good thing, but there is a limit. There is a limit to increase the resources. For example, your laptop or your computer. Currently, let's say it is like of 8 gig of RAM. I can insert 2 chips, it becomes 16. Let's say I insert 2 more, let's say it becomes 32. There are only 4 slots. Let's say I replace those chips with 16 each, then it will become 16 into 4, 64. Let's say I replace that chip with 32 into 4, let's say 128. Then I can keep on replacing the chips, and I would need to just fit those chips in just 4 slots, right? That is the bottleneck of your computer. That is the upper limit of your computer, of your laptop. Similarly, with any server, there is a kind of upper limit with which you can just increase the resources. And forget about this thing. Let's suppose I provide you all of the resources, 32 gig of RAM in each slot. That means 128 GB of RAM. Okay, process the data. You will say, yeah, I will do it. Do it. Then suddenly, let's say your laptop stopped working. Now just do it. What? Yes. Obviously, this is a machine. So what will you do in that scenario? Nothing. Everything will be stopped. But in the real world, we cannot follow this approach. So that's why we have to adapt a kind of distributed approach. Now what will happen? I will not ask you to just process the data, the same data, on just one machine. Then I will simply say, now you have multiple machines. It's very similar. Let's say you are working on a homework, okay? But let's say this is a reality. Let's say you were given the holiday homework, right? Now, obviously, not one or not individual person will do that homework. What will you do? You will create a group and you will complete that homework together. Some part will be done by someone, and then some part will be done by someone. That way, the work will be actually completed faster. Because now 4 people are working on the same data. Wow. And they are sharing the insights as well. What do I mean by sharing the insights? Because you are working together. So you need to communicate, right? You need to say, hey, I have just found this thing and it will be done by tomorrow. Okay. The other person is saying, hey, I have just done this thing, and so on. So you need to communicate, right? So this communication also needed. So that is why this particular design is actually called cluster. You create a cluster of machines, and we also consider machines as nodes. Cluster of nodes. Simple. Okay, perfect. So cluster of nodes. Okay, now what will happen, all of these computers will distribute this data, and it will go to each computer, some part of it, small chunk, let's say here, 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 and here, and they will be communicating with each other. Wow, like this. I hope it makes sense. Simple. They'll be like interconnected. So just tell me one thing, which approach is better? Obviously distributed one. Let's suppose this machine is down. Let's say this one. No worries. These three machines can do the work. And if I have more data, I can add one more machine. I can add two more machines. I can add 10 more machines. There is no limit in adding the machines, but there is a limit to add the resources here. This is called horizontal scaling. Horizontal scaling. This is called vertical scaling. Make sense? Simple. This is vertical scaling and this is horizontal scaling. I hope it makes sense. So this concept is very important because Apache Spark resolves this problem. Not just this, it resolves so many other problems as well, such as processing the data in the RAM, not in the ROM. And obviously that is kind of a different domain in itself. But yes, you need at least some fundamental knowledge here. Being an analytics engineer, yes, you do not need to know all of the things in Apache Spark, but at least you should know PySpark. At least. But you know what? If you would ask me, if you would say, Ansh Lamba, what is your suggestion? I would say, learn Apache Spark as well. Why? But I will say this thing, learn PySpark first, and then when you are comfortable with it, when you are building some projects, when you are working on the real world scenarios, then start learning about Apache Spark, how we can fine tune a job, what is like slave master architecture, what is the edge node, what is all of these things. But first you need to learn PySpark, then you need to jump on Apache Spark. Do not directly jump on Apache Spark because you'll be like, oh bro, data domain is done. So always start with PySpark, then go on Apache Spark. Make sense? Very good. And do you know what? Apache Spark and PySpark, these are totally like open source. You do not need to actually pay. If you want to practice PySpark, you can just go with local installation as well. That would require Docker Compose file. If you do not want to go that way, you can even go with Databricks. Databricks is a platform that allows you to run your Apache Spark, basically PySpark code, for free of cost, because they have launched some free editions for learning purpose. So you can actually leverage it. Okay. Now I'm not asking you to learn Databricks. I am asking you to use Databricks just to run PySpark code. Databricks is actually a different infrastructure that is used for Lakehouse. Here we are only talking about PySpark. I hope expectations are clear. PySpark, only PySpark. Simple. Very good. So because of these advantages, we have Apache Spark and PySpark. Now, one good news is if you are coming from a background where you have worked with pandas, you can easily learn PySpark because it is not very different. It is almost the same. I would say 80% of the concept you would understand like this. Because we work with data frames in PySpark as well. We work with data frames in pandas as well. The difference is here we create data frames which can be distributed, but pandas data frame cannot be distributed. In Apache Spark, we can do it that as well, by the way. But yeah, I don't want to confuse you, so do not worry. So this is the only thing that I'm just focusing right now. Apache Spark and PySpark. Okay. Who is this? Yeah. So I hope now you have the clear understanding what exactly we need to learn and why do we need to learn PySpark. Just to distribute our code to process, because we cannot process our entire data in one machine. Simple. Very good. Now you will say, Ansh Lamba, we work with, oh yeah, I just want to show you one thing as well. So let me just show you that as well. So remember we just talked about upsert, right? Okay. So here, just one thing that I missed. It is just like a kind of example that I want to show. In the real industry, nowadays, platforms like Microsoft Fabric, Databricks are actually handling these kinds of absurd operations automatically. Why? Because this has become such an important thing. Such an important thing. And let me show you that as well. Obviously, you will not understand everything that I will just show you, but you will be able to understand because now you know the concept of absurd. So let me just open, let's say, Fabric materialized views, which is a very new feature in Microsoft Fabric, and they are doing nothing, the same thing. So it is called MLVs. Let me just open this thing. Let me scroll down. Maybe I go to develop. Yeah, I think SQL, not SQL, PySpark. So here, obviously, they are just using this PySpark. You do not need to worry about PySpark. You just need to focus here. At the rate fmlb dot materialized lake view. First of all, what is this at the rate? This is a kind of Python fundamental thing that you should know. This is called a decorator. Decorator, I have literally stressed about this particular thing that you need to learn Python in detail. And in the previous video as well, I have created the Python advanced course. If you have watched it, I will also put the link in the description. Do not need to worry. So I always ask people to learn the technologies in depth. Python is such a thing that is like has become like common thing nowadays. Now, if you want to grow in the analytics engineering domain, yes, you need to make your Python skills really, really strong. And in that video, I have created a dedicated section on decorator just because I know it's important. And you can even see this is the latest framework that is added in the Fabric. It is called MLV, Materialized Lake Views. They are also using decorators. Okay, so obviously we are not discussing what are decorators, but you should know these things. You should know these things. Writing Python functions, loops, if conditions are fine. But what about that? What about after that? Okay, so here they are simply using decorators. And what they have built? They have simply built a direct way to convert your code into an absurd code. So for example, what will happen? Whatever function, whatever code I will write here in the function, okay, what will happen? It will simply apply absurd logic automatically and incremental data logic as well. Wow. Yes. Why? Because they know the importance, and here are the configurations that we need to do. Remember, I told you that we always check the condition on the key column. So see, here is the table properties. Key 1, value 1. And partition column if you just want to do some partitioning, but we are not doing it. So this is the way to actually do it. Okay. You can actually do a lot of things here if you're just doing materialized views. Obviously, you do not need to worry about this thing right now, but I'm just simply telling you these things because if you're just working on the industry projects, you would see these code written directly, maybe on the day one as well. So you should be prepared. Now, what is this thing? This is PySpark. This is PySpark written. So if you know PySpark, then you will be like, okay, I'm comfortable with this thing and I know how to deal with this thing and I'm good. Simple. Make sense? Okay. Okay. So that is it. That is it. And similarly, we have these kinds of declarative decorators in the Databricks as well. And obviously Databricks was the first one to bring this as Delta Live tables. But then they renamed it with like declarative Spark declarative pipelines, SDP. Makes sense. Makes sense. Makes sense. Makes sense. Very good. Now what we need to just do. Very good. Now next topic is I have literally created a list. See, I have literally created a list of topics so that I do not miss anything just for you. And you just need to like this video, comment on this video, subscribe the channel, and you are like, huh. Bro, all the best. So now let's talk about the next topic. The next topic is data modeling. Yes, this is the I know you're just waiting for this one. And you know what, I think this is that particular topic that is the backbone of the entire analytics engineering domain. Incremental load, absurd, these are important. I'm not denying that, and you already know why it is like important. Everything is important, but this is the most important. This is the most important. data modeling. First of all, you need to understand data modeling shift. What do I mean by that? Data modeling shift. Now, we know that we data professionals who are on the other side, like on the data warehousing side, okay? Here we do not perform traditional database modeling, which is also called as relational database management or relational database design. There are so many names to it, right? So here we need to go from RDB design, or let's say modeling, because name is same. Data modeling is data modeling, but you need to understand that it is not the same. So we need to shift our focus from relational database modeling towards dimensional data modeling. Simple. Okay. Now Ansh Lamba, first of all, tell us a little bit about this one. Then obviously talk about this one. So RDB modeling. I would assume that every data professional would have heard about this term. Do you know why? Do you know why? Not because they would have heard about these terms on the job. Because when you study in colleges, universities, enroll in any courses, anything, every database teacher, professor, book would teach you a little bit about database modeling, and they do not name it as relational database modeling. They simply call it as database modeling. Because why? Because dimensional data modeling is just the focus of data engineers, and I do not know why universities, colleges do not like prioritize data engineering subjects. Who is saying that they do not have the teachers? Call me. So, by the way, I only accept IITs. So now RDB modeling means that you need to perform the modeling on the relational database side. Okay. What do I mean? Remember our very first step, data generation. This thing that this data will be stored in the database. This data will not be directly stored in the relational database. Not at all. We need to create a model, and this model is actually very critical, very crucial. Okay, so this data modeling is important. Yes. Do you perform this kind of data modeling? Rarely. Rarely. I'm not saying like no, rarely. But this is your focus. Dimensional data modeling. Ansh Lamba, what is the difference between these two, and how we can just move from one side to another side? And we just need to understand this concept in depth. Please put some more time, more efforts to explain this thing or to cover this area. I hear you, do not worry about that. Let me just do that. So mic check. So data modeling shift. Now I want to explain this thing with an example so that you can understand it. Okay. For example, let's say I have some data which is generated, and that data is written in the form of tables, obviously in the SQL. Okay. Let's consider this RDB first of all. Let's use green color. Perfect. Okay. Now what will happen? We have RDB modeling. With the RDB modeling, what I will do, let's say I have tables like this. Let's say I have one table, and this table is called orders. Then I have products. Simple. And then I have one more table. Let's say line items. Simple. Okay, perfect. I have these three tables. Okay, now I have, or let's say any DBA has created these three tables so that you can just put all of the information of the orders table, orders data in separate table. Then all of the information of the products in a separate table. Line item is basically the connecting table between these orders and products. Why? Because see, one order can have multiple products, right? So one product can obviously have like multiple orders. So it will be like many to many relationship. So whenever we have many to many relationship, we use a bridge. Ansh, Lamba, do you know what? What did you just say? I didn't understand anything. So let me explain. First of all, here, because do you know what this concept is like? You need to be the professor to explain this stuff. Because see, just kidding. So for example, let's say this is a table orders. Okay. Now let's say I have some data like order ID, order ID. Perfect. This is the column, first column, and this is the primary key of this table. I hope you know what is primary key. Yeah, thank you so much. So this is the primary key. Okay. Then I have product ID. Very good. Let's imagine we do not have this table. Okay. Let's say we just have these two tables. We have one table for orders, we have one table for products, and I want to perform relational database modeling. So what I will do, I will simply say I will store here order ID, which is the primary key, and one order can have multiple products. So I have to save product ID here as well. Okay. And this will become my foreign key, because this can have multiple values obviously, but this is not true. Like we let me just use key here just to show that this is a primary key. This is key vault's logo, but it's fine. Let's say this is the primary key. Okay. And this is the primary key. Now just tell me one thing. If I say multiple values of products, can I consider order ID as my primary key? Obviously not, because one order ID can have multiple product ID. So it will create duplicate values. Simple. So I cannot store it like this. So in these scenarios, when you have many to many relationships, this is like many to many, then you have to include the bridge table. So this bridge table will take care of this kind of stuff. So what will happen? It will contain both the keys here, order ID and product ID. Let's say like this. Okay. Perfect. So now what will happen? If you just want to connect orders with products, you first go here and you grab the product ID. Okay. Makes sense. And then you connect with product ID like this. I hope it makes sense. And vice versa. If you just want to check all of the products, same. If you just want to check all of the orders, same. So this is the bridge. This is many to many, but this is not many to many. This is one to many. This is one to many. These kinds of relationships you build within the relational database modeling. Here you use terms like first normal form, second normal form, third normal form. Wow. What are these terms? These are basically the rules which decides your data model. First normal form, let's say, means you should not have any kind of duplicates and you should not store multiple values, blah blah blah. And then second normal form containing everything from first. Then you should not have data in the, you can say, you should not have data combined in one column. Then in the third normal form, everything from second. In the third, you should not keep the data for any other entity. It's like a kind of logics that we create for RDB modeling. It's not our choice. It's totally a business call till which normal form they just want to go with. In the industry, I have seen till third normal form, but they have like till sixth normal form, but till third they are done, because this data model is very simple, but in reality there are like hundreds of tables. Okay. So this is the stuff that we just do with your RDB modeling or database administrators do. Or this is a data modeling that you read or study in colleges, school, courses, books, anything. Makes sense? But this data modeling is not for data engineers at all. Why? Why, Ansh, Lamba? This is doing so good. See, we have orders table, we have product table, just fetch any data. It is working good. Why do you want anything else? See, we work with big data. Okay. RDB database modeling, basically RDB modeling, was designed in such a way so that we can immediately insert new records. Why? Data is being generated rapidly and we need to immediately store that data. That is why it is called transactional database, relational database or transactional database. But in the data engineering world, we do not want to insert the data immediately. We want to fetch the data in a bigger volume. Wow. That is the goal. When we build dashboards on our data warehouses, we fetch data for the entire, let's say, decade just to visualize the numbers, and we want our dashboards to refresh immediately the moment we drag our that whatever you build, that particular knob. So it should be immediately refreshed, right? So you cannot delay, because otherwise those stakeholders will shout at you who do not even know how to build a single page of dashboard. They will literally shout at you, and I do not want that. I literally do not want that. You should shout at them. Try one time. Then tell me what is your experience. So this is your goal. Simple. So whenever you want to go with that kind of modeling, this is called dimensional data modeling. And in some textbooks, in some areas, you will also consider, or you will also hear this concept as data warehouse or data warehousing, so that people do not get confused. It is also a kind of data modeling, but this is a special type of data modeling which is called data warehousing as well. Or more technically, this is called as dimensional data modeling. Makes sense? Because see, there are three layers of data model. The first is business logic, where they just want to design like what exactly they need. Second is logical. Yeah, second is logical, where you simply build the ER diagrams. You are simply saying this will be mapped to this one. Third is the physical one, when you actually build it. That is same. But what type of data model you want to build? This question will be answered here. Data warehousing. Wow. And what is the difference here in the you can say, let's take the same example. Let's say, what will be the difference? So what will be the difference? Obviously, we will use this kind of data model to build a data warehousing. Why? Because that database is our source, and we want to build a lakehouse or a data warehouse. Same thing, because lakehouse is just a modern name. Data warehouse, right? So I have to use this data model to build my data warehouse. This is my source. This is my source. This will still be used, but as a source. Okay. So what will happen? So this will become my source. Okay. Perfect. Now I need to use this source and I need to build my warehouse. So now what I will do, I will first of all create a new data model. And whenever we just create a new data model, there are separate layers. First of all, we ingest this data, extract the data. Then we create something called as OBT. Yes, OBT. So we will simply create OBT. OBT means one big table. So we literally combine all of the tables together that we need for the data model. Let's say I need all the tables. Okay. So I will create one big table like this. One big table like this, and its name is OBT, one big table. And it will have all the columns, let's say order ID, and obviously some stuff, let's say order price, order quantity, then obviously product ID, product name, product category, let's say line item ID, line item ID, then line item blah 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 barcode. Okay, so all of these things will be stored inside this particular OBT. All of the things. This is like one big table. You have literally combined all the tables, and now you have hundreds of columns. Yes, we do it. We do it. Hundreds of columns, I'm telling you. So now this will become my OBT. Now I will break this OBT and I will create my new data model. Make sense? So it is like taking the data, just doing it. Have you ever made any, let's say, I don't know, because I will take that example. Some of you will be like, so let's say you have this OBT, and now after this OBT you want to create a data model. Do you know how this dimensional data model will look like? Let me show you. First of all, we create something called as dimension table. Yeah, dimension. What is dimension? Dimension is a special type of table which stores only the context. Okay, what is context? Context means specific information, textual information that you want to provide, aggregated information that you want to provide, or you can say information on which you can perform aggregation. Okay, and this is rule number 1. Second rule is it should be theme specific. What is theme specific? For example, there should be a separate dimension for orders context. There should be a specific or different table or dimension table for products theme. There should be a separate table for line item theme. So this is theme. That means whenever you store the similar data together, it becomes one theme. So here what will happen? You will create one dimension. So this will be my dimension number 1, and I will call it as, let's say, orders dimension. Okay, very good. And this will be my orders dimension, and here I will store information, let's say, such as order ID. Yes, order ID. Okay, and not just order ID, I can also say order surrogate key. I will just talk about it, don't worry. And then order, that's it. Okay, so I have these two information because this is the only textual information that I have for the order. Make sense? Very good. Now similarly, I will create one more dimension. This dimension's name will be, let's say, product dimension. And what are the context that you can see for products? Product ID, obviously. Context means when you do not have any numbers, we just have context, like textual data. Make sense? On which you can just perform aggregation. So product ID, product name. Very good. Is there anything else? No. Oh, category. Prod category. Very good. This is my dimension, product dimension, but I just also want to save surrogate key. Ansh, Lamba, what is surrogate? Wait. Product surrogate key. So this is my product dimension. Very good. Now I will create my third dimension, which is line item. So let's say line item dimension, and this will be having line item ID. Line item sk empty. This is empty. Line item sk. Okay, and let's say line item barcode. Perfect. So this is my line item dimension. So I have stored all of the textual or contextual information in the dimensions. Wow. Now what will happen? I will create my final table, which will be having all the numbers. Okay, this will be called as my fact table. Okay, so this will be having data like, let's say, let's use Square so that I can just insert some data. So here I will be having, first of all, order sk. I will be having prod sk. I will be having line item sk. I'll be having price, order price. I'll be having order quantity. Simple. So these are the things that I will be having. Wow. This is my fact table. This is like fact order or fact table. Or let's say order is fact. Make sense? This is my data model. Wow. Ansh, Lamba, what actually just happened? Just explain. Wait. I will explain. Don't worry. Do not worry at all. So this is my data model that I have created. Looks cool. And this is the data model that you would have created in reporting tools as well sometimes, right? So this is my data model. Now what actually happened? First of all, let me just explain what are the surrogate keys. Surrogate keys is basically the simple key that we use to join the data. So here I can apply join on order ID. I can say here order ID, but that is not the standard we follow in the industry. We always create a pseudo primary key which starts with 0 or 1. Let's say 0, 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6, 7. Like this. Why it creates those joins simple? Because sometimes, let's say your order ID is such a big ID, 20-digit order ID. It doesn't make any sense to apply join on those big IDs. it makes sense to simply apply joins on 1, 2, 3, 4, 5, 6 like this. Simple. So whenever we create dimension, we store these surrogate keys instead of order ID or product ID. Surrogate keys are nothing but just like your simple keys, pseudo keys, that's it. It is actually equivalent to ID, but just simpler values. Instead of having bigger values, it is just having simple numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Simple. Okay. Then what do? We store all of the context in the tables. After storing all of the context, then we store all of the factual data. What are factual data? Factual data means numbers. I have order price. Yes. I have order quantity. Yes. These two are numbers. Yes. Perfect. And in order to just perform joins with these dimensions, I have to store surrogate key. So I'll store order SK, product SK, line item SK in my fact table. Wow. This is the data model that you need to build now. Makes sense? Okay, very good. This is the data model that we build in Microsoft Fabric, Databricks, all of those popular tools and technologies, frameworks, right? Infrastructure. So I hope it makes sense. Now, what is the advantage of it? This is one of the best model, and I think this was founded by Ralph Kimball in 1980. This is one of the best data modeling design. It was started in 1980, and after 46 years, it is still one of the best. Can you imagine? Can you imagine? I said one of the best. Okay. Can you imagine? Because this actually makes your reporting so smooth. You can literally perform grouping. Let's say you want to find order price on the basis of products. You simply need to join these two tables and that's it. Simply write SQL query where you simply perform join between these two tables. You want to perform some quantity on top of line item ID, you can simply perform this thing like this. Simple. What is the big deal? We work with this kind of data model like most of the time. And before that, we simply create the OBT, which is non-negotiable. Non-negotiable. Now, because you are understanding a lot of things, so in the industry now it is also a popular choice. Some companies do not break their data model like this if they have a smaller one big table. So they simply stop here and they simply create their reports on top of one big table. It can also be the case in your scenario, but you need to know, bro, this is OBT. After that, we can also break this table into a model like this. Make sense? Make sense? Make sense? Make sense? This is the dimensional data modeling or data warehousing that you need to learn, that you have to learn how to do these things. In the real world, we perform Apache Spark, Spark SQL to perform these things. We use Apache Spark or Spark SQL. Okay. Now, let me just tell you the resources as well that you can just use if you just want to learn data modeling in depth. I want you to learn data modeling in depth. I want you, because now you have gained a very strong foundation knowledge. I'm telling you this thing. If you understood this entire flow, if you understood that this is your dimension and why did you create this, I am telling you, your 20 to 30% of knowledge is already gained. Now simply you can start learning about data modeling as well. Obviously after this video, complete this video, there are so much of stuff, but you can just note it down. You have literally gained 20 to 30% conceptual knowledge. It is the backbone of that particular entire concept. Are you getting my point? Are you getting my point? Make sense? Make sense? Make sense? Make sense? This is actually very important. And you perform all of these things using Spark SQL, PySpark, but most probably, I would say, like it's your choice. PySpark and Spark SQL both are same. Both are same from the performance point of view as well. Everything is same. Now, yes, I was just telling you about the resources. See, I can say you that, hey, I have created, yes, I have already created full-fledged data modeling course for data engineers. But now, because you also want to enter into this data engineering domain, you can watch that video that covers everything from scratch, from zero. But I want to tell you the best resource. Ansh Lamba? Yeah, the best resource to master data modeling is the book itself. It is by Ralph Kimball. I can just show you. I can just show you. It is called, I think, Data Warehouse Toolkit. Data warehousing, Ansh, Lamba. Let me just show you this video as well. Not data warehousing. Like I have two videos. One is on data warehousing and one is on data modeling. You can pick any video because like you say you have two videos. See, data warehousing is also a kind of data modeling, but data warehousing covers much more than data modeling. So if you are focusing just on data modeling side, simply watch data modeling video. Okay, so I can literally show you both the things quickly. Data modeling, Ansh, Lamba, and this is the video. See, I think 3 hours of course. Yeah, so this is like purely on the data modeling, basically dimensional data modeling. Data warehousing covers so many things like ETL and all of these things, incremental data, but data modeling is the purely that particular stuff that you just need. Okay, makes sense. So now this is the video I have just literally showed you, and now I just want to show you one more thing. So this is the book Data Warehouse Toolkit, and let me just go to images so that you can just see this is the book. This is amazing book. You can literally go with it. Amazing book, and it was written by, I think, Ralph Kimball. Yeah, Ralph Kimball and Margie Rose. But Kimball is like more popular. Makes sense. So you can just master data modeling from there. But I am happy that you actually understood at least 10 to 20% of the concept, like what exactly is dimensional data modeling, how it is different from relational database modeling, how you need to integrate these things. I am really happy for that reason. Makes sense. I hope now you have this idea data modeling shift, that what exactly you need to learn, right? Very well done. Now let's talk about one of the favorite topics of data engineers. And here, analytics engineer would need a little bit of knowledge, but not entirely, completely, but at least some basics, only basics. Okay. So this area is called orchestration. Because obviously when you just need to orchestrate your entire ecosystem, you have to call data engineer. Okay. But you know what? Orchestration is also not very difficult. It's easy. Why I am why I can literally hear you that you are saying, bro, forget about analytics engineering, just make us data engineers. Are you saying this thing? Welcome to our side. Data engineering is the best. Obviously it is like complex, but the journey is like it's your journey. Obviously you need to enjoy. So let's talk about orchestration. So first of all, what is orchestration? Have you ever heard about the term called pipeline, which is a very popular term? People say, I build pipelines. Yeah, orchestration is more of building pipelines. Now let me just tell you first of all what exactly is orchestration when it comes to, let's say, data engineering or analytics engineering, all of these terms. Orchestration is actually a word that we have taken from the musical industry. Have you ever seen that old guy that do this? Whenever let's say there's a guy who is playing violin, there's a guy who is playing guitar, there's a guy playing whatever, okay, and this guy just do this. What is this thing? This is orchestration. That guy literally holds sticks, and that guy says that, hey, now you need to play. So this is that particular thing. Okay. So we took this word from there because it actually fits in the data engineering. Why? Let's say I have a Python script. Okay. Let's say I want to run this file to fetch some data from the APIs, and then I have some Apache Spark code that I want to run. Okay. Then I want to perform two things. Let's say I want to do something with Delta Lake, and at the same time I want to do something with, let's say, Iceberg, and then I want to create something, let's say, data warehouse, let's say like this, something like that. So I need to create an orchestration. I will simply say, bro, first of all, you need to run. Python will run first of all. This is the first task. Okay. Then you need to run in parallel with this Iceberg task. Then you need to run at the end warehouse. So I have created what? This is my orchestration, simplest orchestration that I have built in just 1 minute. This is what? This is orchestration. I am orchestrating my workflow. I am simply saying, hey, you need to run first, then you both, then you. Makes sense. I am crafting my data pipelines. I am crafting my orchestration workflows. I am crafting what exactly needs to run and when, in which order. Parallelly condition, because see, this is a very simple example. Here when we just build orchestration, we have to take care of monitoring, we have to take care of failures, we have to take care of conditions, we have to run things in loop, we have like so many things. Orchestration is the heart of data engineering. Heart of data engineering. People think that Apache Spark is the heart or data processing is the heart of data engineering. Not at all. It's orchestration, it's pipelines. And do you know what? Nowadays, even AI can write PySpark code. We have like AI assistant in Databricks. I can literally say, hey, just do this for me, just do this for me. It can do it. It cannot orchestrate my pipelines in a production style that I want. Obviously for now, maybe in future, obviously. But for now, I'm just talking about now. The way I want to orchestrate my pipelines, the way I want to add all of those things. Are you getting my point? This particular layer requires experience. Experience doesn't mean 10 years of experience, 15 years of experience. Skills. Experience means skills. Make sense? So here you need that expertise. Expertise is the right word. Expertise is not directly proportional to years of experience. It comes with skills and knowledge, bro. So here you need expertise. Here you need someone who can tell you, oh, okay, this can be the failure. Because see, you cannot just move any code to production and you will be just calling your operations team, hey, this pipeline is broken, can you please fix it? Hey, can you please fix this pipeline? Because data engineers stay on call as well. If you do not know about this thing, data engineers stay on call as well, because data engineering pipelines are so important. If there's a pipeline failure at 2 a.m., they will literally call you, because tomorrow morning everything will be broken. Yes, this is the reality of data engineering. No one will call you if your dashboard fails at 2 a.m. You can fix it early morning. But if pipeline fails at 2 a.m., that pipeline is actually feeding thousands of dashboards. All of the thousands of dashboards will stop running. And there are thousands of stakeholders who are using those dashboards. They will keep on shouting together. That is why we cannot wait. We have to come on call right away. We have to debug the issue right at 2 a.m. and we have to fix it. There's no choice. So that is why we cannot simply ship our code to production. We will say, yeah, we will look into it. If there's a failure, we'll fix it. Not at all. Not at all. Operations team will literally do whatever they want to do. Are you getting my point? So this is the area where obviously kind of AI proof and the real data engineering. This is my favorite, orchestration. So now if you just want to build this kind of orchestration, what kind of options do you have? Because now you understand orchestration, like what is orchestration. Now in order to perform orchestration, if you are coming from the Azure background, which is obviously very popular stack, the options are two. First is Azure Data Factory. You would have heard about this term. I'm so sure about it. Okay. And yes, it is one of the most popular framework. And let me be honest with you. One of the most amazing products in the entire data industry is Azure Data Factory. Entire data industry. It handles orchestration like so good. So good. It is, good news for you. It is not built on top of a pro code approach. It is a low no code ETL tool and still one of the best orchestration tool in the entire industry. It handles literally everything. Amazing tool. Amazing. I love Azure Data Factory. I love it. It is one of the best tools available. One of the best. No one can compete with Data Factory. No one. I'm so sure about it. So this is the tool, And obviously now we have Fabric as well. So that doesn't mean that they have literally ditched Azure Data Factory. No, they integrated Azure Data Factory and they renamed it called as Fabric Data Factory. Do I have logo? Yeah, Data Factory. Now this is called as Fabric Data Factory. So these are the two popular options that you can just use in order to build pipelines, and amazing thing, one of the best. Yes, this comes for Azure tech stack, but if you are coming from any other tech stack, let's say AWS, GCP, there is one more orchestration which is like equally important, because we have other tech stacks as well, and that is also very good, very, very, very good, and that is none other than Airflow. Airflow. Yes, you can also use Airflow. Airflow is also very good. I love Airflow as well, to be honest. It's really good because Airflow gives you the code first approach. If you are someone who likes to write code for everything, Airflow is the choice. If you like low no code, Data Factory and Fabric Data Factory is the go-to choice. Yes, go-to choice. Makes sense? Makes sense, sir? So this is all about your orchestration. This is all about your orchestration. And building pipelines in Azure Data Factory is so easy to get started, but it goes like the projects that I have made, like for YouTube, I have literally showcased amazing approaches and amazing, you can say, real world scenarios where you can actually see the power of Data Factory. If you're a data engineer, bro, those projects are for you. If you are someone who wants to get started with Azure Data Factory, you can literally, I would say, for Data Factory, see, we have a lot of resources. Let me be honest with you. You can directly go to the documentation as well if you want to learn. And if you want to learn from this guy, then yes, I have created one full-fledged course on Azure Data Factory as well. So good news if you want to learn from this guy. So I think I created that course in 2024. So you can literally watch that course. It is for beginners, total beginners, and we cover a lot of things that you need to know as a beginner, total beginner. So you can just go with it. Simple. And it is must for you. This thing, this and this thing, these two things, must. Okay, just learn at least a little bit. And do you know what? If you are someone who is already building some dashboards in Fabric and Power BI, same thing, obviously you can leverage Fabric Data Factory there as well. You can see the power of it. So I think this is a straight plus point for your profile. I'm so sure about it. So sure. Makes sense? And orchestration is actually very, very good. When you just want to perform automation, real automation, this is that stuff. With AI engineering, everyone is like creating a buzz around automation, and we data engineers have been working with this automation since years. The heart of data engineering is automation. That's why you would not hear any data engineer creating a buzz around automation. They will definitely teach you like how to work with those automation frameworks, agentic frameworks, but for data engineers, it's like very normal thing to perform automation. Tools like N8N, these kind of things are like so popular nowadays, but your Data Factory, Fabric Data Factory, Airflow is already there since years. So funny how market behaves accordingly. So this is all about orchestration, and yes, I accept that you do not need a very deep knowledge in orchestration, but at least you should know how to build simple pipelines, how to move simple data, right? Obviously. That is all about orchestration. And what do I have next for your case? Okay, next thing is reporting. And obviously I do not need to talk much more on reporting because see, what do I need to talk on reporting? What? Simply build dashboards, and you should know about reporting as well. So if you are working in data domain, you should know how to build reports. If you are like on the analytics side, okay, I am not a big fan of reporting. Like obviously reports are good. You should have some basic understanding. You should not be a stranger to reporting side. But yeah, data engineers do not work much more with the reporting. But sometimes when they have some basic understanding, it helps a lot to debug any issues that stakeholders are facing. Stakeholders mean like stakeholders of data engineers are you, data analyst and analytics engineers or anyone, right? Because now you are also coming into this domain, the senior domain, or like obviously I'm not calling myself a senior, like I'm just calling this domain as senior domain. Okay, so you are just also coming towards like more technical side. You have decided that you want to go more on the technical side. It is a plus point for you. It is straight plus point for you because you understand this architecture completely. This is in your control. No one can touch it. Even data engineer cannot touch it. So see, you are becoming an asset for the organization because all of the stakeholders, managers will contact you if they want to get any work done. They won't contact any data engineer to just fix anything on the Power BI, build any dashboard. So you are the I told you, analytics engineer is the sweetest spot. Why? You do not need to be very, very technical. And at the same time, you are customer facing, you are managers facing. So your chances of growth are actually very high. This is a sweet spot. You need to grab this position, bro. You have to do the hard work right now and you have to grab this position as soon as possible, because obviously they will not hire many people like before. You can see like AI is here, but this is a time. Grab this position. This is the powerful position for you. You own all the reports. You know how to work with data engineering stuff. Okay, not entirely, but at least some of the stuff. Cool. Okay. So, Ansh Lamba, thank you so much for motivating us. No worries. Anytime. So, this is all about reporting. And now we want to talk about very, very popular. And whenever we just talk about analytics engineering, we have to talk about this thing. And I know you have guessed it. It is called DBT, Data Build Tool. Data Build Tool. What is this thing? Because I know you would have some misconceptions about DBT, and because this is a new tool, because this domain is also new, let's talk about this tool in detail because I want to put extra efforts on DBT. I would also show you a quick demo of DBT, very quick demo, so that you would understand this tool better. And now, why did I just include this tool towards the end of the video? Because now you have this knowledge. This entire knowledge is required before jumping directly on DBT. Nowadays, what is happening? They heard, oh, analytics engineering. Okay, let's apply for this role. Okay, what is the tool required to just get into this field? DBT. Let's learn DBT. DBT is not just a tool. DBT again is an infrastructure. DBT helps you make slowly changing dimensions. Do you know about slowly changing dimensions? DBT helps you perform upsert. Do you know what is upsert? Now you know, like before, if let's say you directly jump on DBT. DBT helps you to build the dimensional data model. Do you know this thing? DBT helps you to perform incremental load. Do you know this thing? DBT helps you to work with Delta Lake. Do you know about this thing? Now you know. Before you would not know. And do not worry, because I just used a word slowly changing dimensions. This is the word that I will be just considering under this section. Ideally, that is a concept that falls under dimensional data modeling. That is a concept here, but I want to talk about that topic here because I want to show you the demo as well. And I didn't want to show you the concept and demo later on because it breaks that link. So I just wanted to show you the demo as well right away because that is a kind of most complex concept that you would have heard. But do not worry, trust this guy. I will just try my best to explain this thing. So Ansh Lamba just explained DBT finally. So now let's talk about DBT. So first of all, let me just tell you what exactly is DBT, because I know this tool is rapidly gaining population and it should be. By the way, let's talk a little bit about DBT in detail, because DBT is, yes, a kind of that tool that you should know if you want to grow in the analytics engineering domain. But this is not just the only solution that you need in analytics engineering. I have seen like a lot of companies work without DBT as well to manage all of these things. It's all about how well you can write your code. Okay, but DBT solves that problem who do not want to write all of that code from scratch. So yeah, so let's talk about it. First of all, what is DBT? DBT is data build tool. Okay, makes sense. We can see the full form, but what is this tool? This tool actually solves one problem. And before I'm talking about the problem that it solves, let's talk about what this tool will do in our data lifecycle, where this framework, where this infrastructure actually fits in our lifecycle. So let's see. So if I just go to my lifecycle, if I go to this thing, okay. So DBT can be integrated here and here. So this is the area where DBT can fit. Okay. In data transformation and data modeling as well. Data modeling as well, yes. You can literally build your facts and dimension tables with DBT. Because with the course of time, it involved some you can say improvements as well, and they just added some functionalities with the help of which you can literally build the entire data model with DBT. Okay, so one thing is clear that we just work with these two areas, let's say in the DBT. Okay, makes sense. Okay, perfect. So this is the area where we can just work with DBT. Okay, let's say this thing. But what exactly we need to do? What are the skills that we need to work with DBT, and what exactly we can just do with DBT tool or technology? Because being a beginner, I hope that you would not have even heard about this term DBT. So let me just tell you. So DBT is all about SQL first approach. Okay. It's a SQL first approach. That means you do not need to write any Python code, you do not need to write any PySpark code, but still you can perform data transformation and data modeling. Ansh, Lamba, is it magic? Because you said that we use Apache Spark and we work with Apache Spark to transform our data, and we perform same operations in the data modeling as well. So how can we just use SQL and it will do everything for us? Remember, I told you that within Apache Spark, we have two things, PySpark and Spark SQL. Yes, you need to know PySpark because there are a lot of things that you need to do in data extraction, data transformation, everything. But some part of data transformation and data modeling can be totally relied on SQL. Totally. Okay. For example, let's say you want to transform your data, right? And you know how to write SQL queries. So you can write SQL queries and this engine will run all of your queries in the Spark SQL. Okay. And you will get the same results. Again, I'm repeating, it will not replace all of the transformations that PySpark handles because you still need to perform a lot of utilities, modules, creation and all of these things. But like you can say a very good proportion of that transformation can be done via DBT just using SQL. So we just need to know SQL and it's done. Yes, just SQL, not just SQL. So first of all, obviously SQL. And if you know SQL, after that, you should also know something called as YAML. YAML is basically a file format, which is nowadays very, very popular. And what it does, it is used to perform your, let's say, configuration. Okay, YAML. And this is very similar to JSON. If you know how to work with JSON files, it will hardly take, I would say, hardly 30 minutes to go through YAML file formats, indentation and all. It is very same. So YAML is the key. And third thing is Jinja. What is Jinja? Jinja is basically, if you are coming from software background, web development background, if you did BTech, I would say you would have learned about this concept called Jinja templates. So these are the templates that we use in order to create, you can say, modular code. Now, what is modular code? Modular code is the code that we use to create templates. Because we can just rewrite our logic every time. It is possible, but we should not rewrite everything. Because we use a concept called never repeat yourself, right? So we need to create queries, SQL queries, but not just hard-coded SQL queries. We have to use something called as Jinja templates within that query. And do not worry, I will just show you all of these things quickly. Do not worry. But first, I want to build your strong foundation. So here, if you are writing queries like this, let's say select asterisk from table, let's say orders, where whatever, let's say order ID equals to 1. Okay, now let's say I want to make this code modular. So what I can do, I can literally declare a variable here using Jinja. So it goes like this. Oops, let's say I'm defining any variable. Let's say variable equals to something, let's say 10, and then I can just use this variable here instead of just using that thing. So it is a kind of modular coding. I will just show you the exact syntax. I'm just giving you some insight so that you can just understand. So this way you can just build queries which are actually modular. You can reuse it multiple times. You can just scale it anytime. Simple. But why do we need to learn YAML? So in DBT, whatever you define, let's say you want to perform data modeling, you want to create fact table, dimension table, you want to incrementally load your data, you want to, let's say, do anything. You just write SQL queries. But SQL queries is just the what part. What, like what you want to do, what transformation you want to do, what model you want to build. But how you build, how part is what is this YAML. Okay, so DBT says that you do not need to perform the how part. We will take care of it. If you want to incrementally load the data, we will do it for you. If you want to build slowly changing dimensions, we will build for you. If you want to build a star schema, basically facts and dimension tables, we will build it for you. But you at least need to tell us. Okay, so that tell us part is this thing, YAML. So you simply create a YAML file and you tell everything that I want this, I want this, I want this, and DBT will take care of everything. It is very similar to, let's say you go to a restaurant. Okay, now obviously you will not cook food. Chef is there, but chef at least needs your input, that what exactly you want to eat. And sometimes you also add some customization that I do not want this food to be very spicy, just keep it low and all of these things. So you need to tell those things, right? You cannot simply say, I will sit at the restaurant and I will get the food. Obviously, it is not possible. So you have to tell that first of all, what exactly you want and any kind of customizations you want, any kind of sizes, let's say small, medium, large, whatever. Small, medium, large, whatever. Okay, half, full, whatever. So you have to tell all of these things. So all of these kind of configuration will go under YAML file. You will prepare one YAML file, which is the source of truth for your entire project, and DBT will read all of the instructions from this YAML file and it will prepare everything for you. So in DBT, you just write SQL queries and all of the complex parts, incremental load, upsert, slowly changing dimension, data modeling, everything will be taken care by DBT itself. That is why this tool is booming. Why? Because nowadays companies want to hire analytics engineers, and obviously analytics engineers cannot perform all of those tasks without the help of data engineers. Obviously, when you just want to build a robust solution, you need a data engineer who has like expertise. But let's say you do not have that talent in your organization, maybe then you can literally offload that work to DBT and DBT will do all of that stuff for you, and analytics engineer can just literally define what they want and they will get the work done. And nowadays you can even combine DBT with your agents. I think DBT just launched some agents as well. I have not explored it yet, to be honest, but even without DBT you can just connect it with like Claude Code as well. They have like MCP servers, so you can literally ask those things to create YAML file, to correct it, to do anything. So again, I'm repeating, DBT, or you can say analytics engineering domain, is actually very good area for all of the beginners. Very good area, very strong area. And when you master DBT as a tool, you first need to understand all of the things that we have discussed in detail. And when you then learn DBT, you actually become an asset for the organization. Because DBT does the how part. And if you have zero knowledge of that how part, I know DBT is doing everything for you, but if you do not have any knowledge of how part, you cannot debug anything. It's very easy to show you a demo, hey, just build this thing. Okay, it is in production, fix it. Something is broken, fix it. You cannot do it if you do not have how part knowledge. So even DBT is doing everything for you, you still need to have some basic understanding what exactly and how it is doing. Make sense? Okay, I know you just need to provide YAML file, but how this YAML file will be executed? How? Make sense? Very good. Now, this is just the first problem that your DBT solves, which is like purely SQL first approach, and you do not need to write the code for everything: incremental loading, your slow changing dimensions and fact tables, data modeling and all. Don't worry, we'll just talk about this thing a little bit in detail. Okay, do not worry. So now the major problem that DBT solves after this is DBT is actually an adapter. Wow, what is this adapter? Let's say, because see, what is DBT? DBT is not a storage solution. DBT is not a kind of, you can say, computation solution. Yes, DBT doesn't have any kind of server. What do you think? Where the SQL queries are running? What do you think? It doesn't have anything. It doesn't have anything. It doesn't have any kind of SQL server, any kind of Spark SQL server, nothing. Then Ansh, Lamba, where our SQL queries will be running? That's what I'm actually discussing right now. So you simply use your existing data warehouse, Lakehouse. Let's say you are using Databricks. So let's say you are using Databricks, okay, as your major storage solution. Not storage, because like you can say it as storage as well if you are just creating managed tables, then yes, obviously. But yeah, so let's say you are using Databricks for building the Lakehouse. You are creating tables here. You are using clusters, Apache Spark clusters to process your data, right? So what you will do, you will simply say, keep using your Databricks. I'm not saying that you need to replace it, but please include me as your connector, as kind of adapter. So now this DBT will be connected to Databricks. Now DBT will send all of the SQL queries, modular code, and it will be running under Azure Databricks. Wow. And all of the tables, schemas, data models will be created inside Databricks. But DBT will tell what exactly you need to run. And if you do not use DBT, if you, let's say, do not use DBT, then there will be a developer who will be telling all of these things. This is the difference. Make sense? Now, obviously, you need a developer for DBT as well, but it's very easy. DBT is very easy. So this is the major difference. Here, this person is telling that you need to do everything. That you need to do this, you need to do this, this is my code. But here, DBT tells what exactly you need to do, and you just tell this DBT that what you need. And this part is very easy. This is not very complex. This is the area where even beginners can grow and shine. Simple. But beginners means, who are beginners? Who are beginners? Beginners mean, let's say, you do not have expertise, but you have skills. So skills are non-negotiable. You still need skills. You still need knowledge, right? So this person can literally just perform some DBT tasks and everything will be available in the Azure Databricks. Now, Ansh, Lamba, you took an example of DBT with Azure Databricks. Let's say my company is using Fabric. That's why I told you it is an adapter. So let's say your company is using Fabric. Now it can literally connect with Fabric as well. Why? Just tell me this thing. Why it can connect to Fabric as well? Because Fabric can also run your SQL code using Spark SQL. Fabric has also has some support of, not some, like total support of Spark SQL. It can also run it. Wow. But Ansh, Lamba, Databricks way of creating tables, Databricks way of creating models are different from Fabric to some extent. Yes, but they have built-in integrations available. So you simply use an adapter. So whenever you connect with any kind of Databricks or Fabric, you first pick your adapter, that which adapter you want to pick. Fabric, Databricks, anything. You can even connect to Snowflake, because Snowflake also uses SQL under the hood. So SQL query is not being changed, only the infrastructure is changing. Okay. And if there is any change, because obviously there will be some slight changes between running queries in Databricks, running queries in Fabric, and running queries in Snowflake, there will be a minor difference, but those minor differences will be taken care by DBT because it has created dedicated adapters. There are, I think, 5 to 6 adapters. I can just show you. Oh, don't worry, I will just give you a very quick brief of DBT as a tool as well. Do not need to worry. Okay, so this is your DBT. It first solves this problem, and it solves the problem of your changing your storage solution, processing solution, all of these things. So DBT actually sits as a kind of guard, or you can say a kind of layer which protects something called as vendor lock-in. Are you getting my point? Because you can literally use Databricks and then you can just switch to Fabric and then so on. Here, the problem was companies were hiring Databricks developers, then they were hiring Fabric developers, then they were hiring Snowflake developers, then now they just want to hire DBT developers, and DBT developers can take care of these things. Now I am not denying that you do not need Databricks expert, Fabric expert, Snowflake experts in your organization. You cannot afford this particular thing. If you are thinking this thing, you are wrong. You still need Databricks developers, Fabric developers, Snowflake developers. They are non-negotiable because they maintain the entire ecosystem. But earlier, let's say we need 10 people to work on Databricks. 2 to 3 will be Databricks experts, and 6 to 7 people will be performing some minor stuff like transformation, building notebooks, and all of these things. Those 6 to 7 people can now, these analytics engineers who can work with DBT directly, and they can build models with Databricks. And now Databricks supports DBT jobs as well. Fabric has now started supporting DBT jobs. That means Databricks has accepted DBT. Fabric has accepted DBT. I don't know about Snowflake, but these two are done. That means they are also encouraging that you can just use DBT because it actually solves the problems. Makes sense? Now, if you are coming from Azure Databricks background, if not, it's fine. But if you are, then you can think of DBT like, because Databricks also has Delta Live tables, or you can say Spark declarative pipelines, which is actually doing something similar, but just for Apache Spark. So if you are coming from Azure Databricks, then you can say, yes, DBT is very much similar to declarative pipelines. And obviously, if you are a Databricks developer, you should focus on that instead of DBT because it has a better integration, better support. But if you are not coming from that background, then yes, DBT is the solution. Okay. I hope it makes sense. I hope it is clear. So this is your DBT under the hood, like what exactly the DBT is. Now, why the demand of DBT is growing? Because DBT can handle your entire infrastructure by its own. But do you know what? DBT is not just a simple tool. DBT is not just a tool that you can just say, hey, I will just simply learn it like this. You still need to put some dedicated efforts to learn DBT. Because when you are, just think about it, you are literally managing the entire infrastructure using just one tool. That means you have to just know a lot of things. And even if you just read the documentation, by the way, DBT has maintained amazing documentation. Well done. Even if you just read the DBT documentation, within just 5 to 10 to 30 minutes, you will realize that if your fundamentals are strong of data engineering, then only you can work with DBT. If your fundamentals and all of the things that I have discussed before are not strong, DBT will feel like, I don't know what I'm doing. That is it. Because DBT is a solution just to make that work easier. If you do not know how to perform that work, how can you just feel that it is actually making the life easier for those developers? Simple. Very good. Now let's explore a little bit more in the side in DBT. Let me just search. And by the way, yes, DBT is also free and paid as well. So DBT is a kind of open source project that we have, and they have one cloud version as well where you can just use, obviously the organization can use DBT for their own work. But being a developer, you do not need to pay at all for DBT. You can literally download it on your local machine and you can just start building, or you can even start building on the cloud version. It is free for just one user. Like you can just create an account and you can just use it to learn. That's it. Okay, just a kind of similar way like how Azure and AWS provides you some free access, but DBT doesn't restrict you to use the services after 1 month. One month you can still use it, and it will not, I think, charge you. So it's free, but not for organization. It's not like free. It is just free for the learning purpose. Okay. By the way, I also have like one dedicated course that I just launched, I think last year in the mid, about DBT. And if you haven't watched that thing, then I can just show you. DBT Ansh Lamba. So I think this is the course. This is like 5+ hour course, and this is the course where I have used open source DBT, which is like local installation, so that you can just go with that thing without any kind of subscription or anything. So this is actually very good solution. And if I just show you the DBT documentation, so DBT developer hub, not this one. Oh yeah, it's this one. Okay, documentation and references. So here you can just read about the documentation. Let's go to APIs, not APIs, I think product documents are enough. So there are multiple things that you can just do. So if I just quickly go to DBT quick starts, so here you will see that they have all of these adapters: Athena, Synapse Analytics, BigQuery, yes, Google BigQuery, Databricks, Fabric, Redshift, Snowflake, Quick Start, and Teradata. All of these are the adapters. Wow. So that means you can literally use DBT, and that same DBT can do the work for all of these things. Wow, that's actually magic. And if you just want to install DBT locally, you have DBT Fusion engine from a manual install, DBT Core from a manual install. There are basically multiple engines. DBT Core is the real original engine, and DBT Fusion is the, you can say, updated engine that they have just launched. Earlier DBT Fusion was in preview, but I think DBT Fusion engine from a manual install, I think they have just made it available. If I click here, you will see that you can just download it in VS Code. Okay, there are some commands, I think. Visual Studio Code, the open source AI code editor. Wow. So they have just made some improvements as well in their engine, but DBT Core is the original traditional engine that they used to just get started with DBT. Okay, and you can just read it. By the way, this documentation is very good, very rich, and they have actually explained everything in detail. Very good documentation. So you can just go with this documentation as well. And now I also want to show you how you can also create one DBT free account, because it will be very beneficial for you. Yes, when you will be just watching that video, that course, it will just tell you how to install DBT locally. It's just 1 to 2 commands and that's it. But even before starting up DBT locally, you need to just spend some time to configure it, to create profile, to create the root YAML file, and just to do all of those things. But when you just create the cloud account, it's much easier, and you do not need to set up your environment because you are using the cloud account. So you can also create it. I think you can go here to, let's say, DBT Labs, and if you just go to here, login and create a free account. So you can click here on create a free account, and then you can simply create it. Simple, just put your information, email, name, and blah blah blah. You can put any email ID. There is no need to put your work email ID. It works with your normal email ID as well. And when you will be just creating your account, then you will land on the page, and I can just show you my demo account that I just used to create tutorial, and let me show you that as well. So I am here into my one of the DBT projects that I created for YouTube. It is like PySpark DBT project. So I created one project, end-to-end project, where I just combined PySpark with Databricks and DBT. So obviously we are not learning the project here, or we are not building the project, but I just want to show you some of the files that we created within this project, and you will have a little bit of understanding. And then I can just show you one quick demo of like from scratch, so that you can also like get started with DBT easily, because it will give you a sense of, you can say, action that you can just take. So I will simply go to Studio in the DBT. And obviously in your case, it will be totally different because yours is like a purely new thing. So let me just close all of the tabs and let me just show you. So this is my DBT Cloud File Explorer, which is the root of my project that I built. So the beauty of DBT is, there are so many beauties, but one of the beauties, you can even version control your code. So you can see here version control. That means you can just, you can say, create branches. You can just take care of the history, that what you have committed, and all of the things that you do with the Git. Git is basically one of the most popular version control software that we use, and it also uses Git. So you can literally integrate your GitHub repo if you have one, or you can also use the built-in repo. Yes, DBT also has one built-in repo in order to just create pull requests and just to merge branches and all of these things. Simple. And now if I just click on this folder, I will see this kind of structure. Wow. First of all, let me just tell you what are all of these things. So first thing first, you always get, and don't worry, I will just show you one quick demo from the scratch. I just want to show you one most important thing. So let's say we have here these components: analysis, macros, models, seeds, snapshots, target, test. These are basically the components. Now what do I mean by components? So here I told you that in DBT we just write SQL and we just tell how we want to do it, right? Just the steps, just the configuration. So let's say inside models. Now what are models? The backbone of DBT is just the models. So let's say you want to create a table, you have to create a model. You want to create a view, you have to create a model. You have to create, you can say, your dimension tables, you have to create a model. So everything is actually a model. Okay. So if I just expand this, I would have some files: sources, silver, gold folder. Within that, I have one, let's say, trips.sql file. If I just open this file, what I will see, wow, I can see something related to SQL, but it is not actually SQL. Yes. What is this thing? So in this, what I told you, so we use Jinja. So this is what? This is Jinja code that I have used within my SQL query. See? So here I remember, like in this project, I built one, you can say, automated way of creating, or this is also called as metadata driven approach to create silver layer. So in this particular file, I created the silver layer for my data engineering project, and I used this particular file to create dynamic SQL every time. So what I'm using, I'm simply using a for loop inside SQL. Yes, you do it with Jinja. And here you can simply select the columns that you want and it will automatically do the work for you. So I built this thing for silver layer. I remember, I think this was the project. Yeah. So this is the thing that we built in Jinja. Okay. So this is the way that we just write our SQL. So yes, SQL is a backbone, but concepts are more important, because do you know what? I am doing incremental loading in this particular file. See, where last updated timestamp greater than this query. So I am doing incremental loading. So if you know the concept of incremental loading, then only you will understand this code. Otherwise you will say what this code is doing. Make sense? So I just wanted to show you this file specially, because you know SQL, but you also need to know that SQL alone is not enough. SQL needs to be combined with your data engineering concepts, plus some of the skills that are required within the DBT itself, like Jinja. Then you become like analytics engineer. Yes, SQL is the backbone, but SQL alone is not enough. Not enough at all. Okay, very good. So now, Ansh, Lamba, this is SQL. And what this SQL is actually doing, you said that you are creating a silver layer table. Yes. Where is the table definition? That is the power of it. I do not need to define how to create a table. I simply need to say that what exactly I need inside my table. I need this thing. So I will simply add this file inside my models folder, and when I will run this model, it will automatically create a table inside Databricks, because my current DBT project is linked with Databricks. If it is linked with Fabric, it will create a table in Fabric. If it is linked with, let's say, Snowflake, it will create the table in Snowflake. Simple. But this code will remain the same. This is the problem, major problem that DBT solves. Why? Because you do not need to change your code. You just need to change your vendor and that's it. Make sense? So this is like one of the things. And Ansh, Lamba, can you just show us that YAML file? Yeah, sure. So this is my dbt project.yaml file that I have created. This is a kind of file that, see, we simply add key value pairs. So this is the name and this is project name, version of file, config version 2, then profile, then model paths, analysis paths, test paths, seed paths, all of these things. Path means like where I have saved all of these things. Okay, and these are my folder names. So this is a kind of YAML. First of all, gain strong hands-on how to work with YAML. Okay, because YAML is important. Then you will learn how to build this kind of file. This is the project file. I know you are very overwhelmed by looking at this code because obviously this is a complete project which is already built. But now I want to take away your fear. Okay, now I want to show you one simple project, not project, like quick demo, how you can also get started with your DBT. And what I will do in this particular demo, I will take my Databricks, and do not worry, Databricks is also very easy. You can literally create a free account. So we will first of all create one staging layer in Databricks. And what we will do, we will perform end-to-end example. We will read the data from the Databricks, we will transform it, and we will write the data back to the Databricks using DBT. And obviously we will not cover complex concept, but very simple one. Are you ready? Let's do it. So in order to get started with Databricks, you simply need to search and just type Databricks, and you will just click on the first link, and then if not this link, then you can simply say Databricks free account. You will land on the page, because whenever you use Microsoft Edge, this browser is like Databricks free account and discover Azure Databricks. What, bro, are you serious? Yeah, sign up. So this is the page that you can just use, and when you just land on this page, make sure that you are seeing sign up for free edition. In some cases you will see just Databricks free edition and sign up for Databricks. Just you need to go with the Databricks free edition, and you can just confirm it by here. Sometimes if you just see something else, there will be a link somewhere here to go to the free edition. Just make sure you are in the free edition. So you can just literally sign up for the free account, and you can use your Microsoft account or Gmail account, and you will be able to use Databricks. Yeah, it's very simple. And once you create your account, simply need to go to your Databricks service, and I can also log in quickly. So this is my account. So I will simply say personal accounts and click here, and you will land on your Databricks. So simple, very straightforward. So now this is the UI, and obviously we are not covering Databricks here, but we simply need to use Databricks as our data storage and data processing solution. You can use any other solution, Fabric and all. So let's say you are using Databricks. So what I will do, I will simply click on catalog, and I will create a new catalog. I have a lot of catalogs, simply ignore. So I'll simply say plus sign and create a catalog, and this catalog name, let's say DBT tutorial. Simple, standard, use default storage. Yeah, default one, create. So this will create a catalog for me. Configure catalog, simply say I'm the only one using this, so simply say okay, it's fine, next, save, and that's it. So this is my catalog created, which is called DBT tutorial. Simple, good. Now what I need to do, I will simply create one schema. Okay, so just click on this catalog, and then click on create schema. Let's create a schema called STG, which is staging. Okay, and then click on create. So this has created one schema for us. What is a schema? Schema is similar to the schema in SQL, like DBO, public, all of these kind of schemas. Here we have created schema called STG. Okay, and you can see all of the information here, and we literally do not have anything. But obviously if we want to load some data, we want to work with some data, we should have some data. So you can literally upload any file, anything into the schema, and it will create a managed table on top of it. Let me just do that quickly. Okay, so here I will be using my one CSV file. I have just created one demo file. So what you can do, click on the schema and then click on create, and there you will see table. So it will create a managed table, delta table for us, and I will upload this file here, fact bookings. So this is the file name, and it will just display the data to me. I will also upload the file in the GitHub repo. You can just simply take it from there, or you can use your own file. It's actually not a big deal. Just upload any file, CSV file, anything. So now it will take some time to show us the table, because it will turn on the cluster, and I think serverless starter warehouse is started, and all of these things are for free. So this Databricks cluster is also free. You do not need to worry, because this is a free edition. So let's wait if we can see our data, and then I will just simply create the table. Perfect. So now your table is being created. So now the requirement is, we have a table. Let's say we have simply fetched some data from anywhere, and we dumped that data in the staging schema, which is equivalent to raw layer, or you can say staging layer before raw layer, right? Now I want to create, let's say, a transformed table out of this fact bookings. Okay, because I have these kind of things. Let's say I have booking ID, passenger ID, flight ID, airport ID, amount, booking date, everything. Simple, makes sense. I can also preview this data just to see what data do I have. Click on sample data and you will see this thing. Okay, so all of the information is here. Make sense? Good. Now the thing is, I want to use DBT, and when I want to use DBT, I want to take this data and I will use SQL Power. SQL Power means SQL skills, and then I will transform this data, and I will not write any kind of command, any kind of thing, but I want DBT to perform everything for me, and it will automatically load the data back to this particular Databricks automatically. Okay, and by the way, I'm again repeating, if you just want to learn DBT in detail, yes, you can just go to that particular course, but here I just want to show you a simple demo and that's it. Just set the expectations, because if you just want to learn things like incremental loading, schema modeling, and your slow chain dimensions, all of these things, then obviously you need to spend dedicated time. So now what I will do, I will simply go to my DBT, and from the sign up page you can literally log in. Okay, and I already have logged in here, so I will simply go here and I will click on my dashboard and just leave it, and perfect. Now here, first of all, I would need to delete my current project. Okay, so let me just quickly do it. So I have literally deleted all the projects that I had so that you can also see it. So here, if you will see, you will also see this thing, set up a new project, and here the project name will be analytics or anything. By default, you can literally provide any project, and if you are on the free version, you can only create one project. So that's why I deleted my previous project. So let's say the project name here is DBT tutorial or demo, not tutorial. Let's say DBT demo. Perfect. And if I just say, let's say DBT demo. Okay. So now what I will do, I will simply say advanced settings and it is fine, and simply go to continue. And here it will ask me to create a connection. What is the connection? Remember when we were just talking about DBT? So we need to connect it to any kind of storage solution, processing solution. This is an adapter. So here we need to pick the adapter. So here I do not have any kind of connection. So I will simply say add new connection, and it will take me to the connection tab. So here I need to pick one of the you can say solution that I need to pick. I have Teradata, Starburst for Trino, Athena, Fabric, Synapse, but I want to pick, let's say, Databricks. Oh, they have PostgreSQL as well now. Nice. So I want to pick, let's say, Databricks. Click here on the Databricks, and connection name, you can say Databricks connection, like this. Perfect. And after the settings, we need to provide some more information. So just go to your Databricks tab, and here what you can do, simply go to SQL warehouses and then go to your SQL warehouse, and then just go to connection details and copy the host name and put it here. This is the, not this one, I think this is the one. Yeah, this is the connection name, and here in the HTTP path you just need to copy this thing. Perfect. So these are two things, and click on optional settings. Catalog name is our, I think which catalog did we create right now? I think Databricks demo. Let me just confirm. If I just go to catalog, I can see DBT tutorial. Okay. DBT tutorial. Yeah, DBT tutorial. Okay, let me just change it. DBT tutorial. Okay, cool. So this is the thing that I just want to do. Now simply say save. Now this connection is saved. If you just go back to the previous tab, you can just pick here connection. Maybe it is not refreshed. So let me just refresh it. So project name array again, DBT demo, then continue. Something went wrong, please address the issue below. What? You can only have one project. So what project do I have? Go to Databricks. Oh, because that was already saved in between. Okay, click on the existing project, DBT demo, click on update, and if you just go to connection, simply go to pick this connection. Very good. And this is the thing that now you need to provide, development credential. So DBT will be accessing your Databricks. Who is DBT? Who is DBT to access your Databricks? No one. So you need to allow DBT to access your Databricks, right? So you will do what? You will provide a token. So now from where you can just get the token, let me just show you. So you simply need to go to this tab. Where is the tab? Here. So here, go to this icon and then settings, and I think there'll be a users tab here, access, and I think in the users, okay, this will manage users, so not in the users, it will be in developer, I think so, yeah, then access token. So click on manage, and here you can just generate one new token. So let me just click here, generate new token. So I will simply say DBT demo, simple, and you can simply say lifespan 90 days, API scope, like what it can do. Let's say all APIs just for now, because it is a free edition, so it is fine. So it will generate a token for me, and now you need to paste that token to the DBT. Let me just do that. So I have created this particular token, and I will simply paste it in my DBT. Okay, perfect. And schema is DBT Lamba. What is this thing? So whenever DBT creates any table, creates anything, it will simply ask us to pick a schema name. By default, it picks DBT as my prefix, and it will take my Lamba as my suffix. It is good when you are in the development layer, when you are in the dev environment, when you can just have multiple developers, so that no one actually rewrites anyone else development. So it is actually a good way, but in production we simply rename it. Okay, but for now it is good. Target name is default, it's fine. Simply say test connection, just to make sure the connection is fine, and once it is done, then we can just go ahead. Testing connection, it will take some time, maybe a few seconds. Okay, perfect. Simply say save, and this particular project is done. Now it is saying which Git service you want to pick, GitHub, GitLab, or Git clone. I want to pick managed, which is the existing DBT Git software. So I'll simply say managed, but you can also say GitHub or GitLab if you have like a repository built there. It's exactly the same. Simply say managed, and then repository name. You can create a new repository. Let's say new repo DBT. Create, and perfect. Now your repository is ready. Now we can start developing in the studio, get started with CLI, check out the getting started tutorial, and much more. But I will simply say start developing in the studio. Studio means this studio. We can actually click directly here as well, but let's click here. So this will open and create the entire project for me. Let me just close unnecessary tabs. So perfect. So this is my project. Wow. First thing first, I need to initialize my DBT project. So if you have some Git knowledge, you would know that we have to register our initial commit. So this is that particular thing. Simply say initialize DBT project. It will create the commit. Perfect. And you will see all of the folders here. See, all of the folders are here. Analysis, macros, model, seed, snapshot, test. Obviously these are empty. See, every folder is empty. We just have .git keep file, because if we just want to just commit our folder, we have to store the git keep file. It is a different thing, but you will see some files in the models. Why? Because DBT provides us some sample files with the help of which we can actually do something, but I do not want anything. I will simply delete it. I will create my own files. Okay, I'll simply say delete and delete here as well. Perfect. Very good. So these are all of the things that we have. I will also say delete it. Schema, do I need schema? Schema.yaml, no, we do not need anything. I will literally delete the entire examples folder because we have one folder inside models. I do not need that. Perfect. So these are all of the components, and if you would remember, I told you that each component serves a different thing, right? So first thing first, you need to configure your dbt project.yaml file, which is this .yaml file. So if you will see here, you have the project name, my new project. You can literally say it anything. Let's say DBT tutorial or whatever, because this is the name of your project, right? So let's say I want to call it as DBT demo internal. Okay. Then paths are same, because I am not changing any naming convention of these folders. It is fine. Then it is saying target path. Target path is the target where it stores your, you can say, rendered code. It's totally DBT thing, just ignore. This is important. This tells the DBT how you want to materialize your objects. What is materialization in DBT? Let's say you want to create a table. So you will simply write it here, table. But let's say you do not want to create a table. You want to create a view. Then you will write view. Wow. Yes. But I want to create table. So I'll simply say table. Okay. Now, what is the difference and how do we configure it? So it means whatever files I create under models folder, whatever files, all the files should be materialized in the form of table, all the files, but inside example folder. But I deleted that example folder, obviously. So I have to remove this example folder like this. And I need to indent this materialized towards backwards like this, because indentation is the key of YAML file. Now what will happen? All of the files directly inside the models folder will be treated as table. Okay, under models. This is my personal change that I have made. Very good. Now what I will do, I will simply create one simple demo file inside models, and I will create this file from here, and this is my file name, and I can keep the file name, let's say, let's rename it. Okay, I have to save it first, so it's fine. So literally say select asterisk, like simple SQL query, select asterisk from stg. What is stg? My schema name. stg dot table name was fact bookings. Simple. This was a file name. Okay. And now I have just simply clicked Control S to save this file. You can also click here, save as, and I will say demo.sql. Okay. Now you will see models has one file, demo.sql, where it has saved it. Oh, so it literally saved outside my model. So you have to move it like this. Perfect. So now I have demo.sql inside models folder, and just keep it in your mind. It is important. You have to just store the file inside models. So this is my file, but I don't want to just do this thing. I want to perform some transformations. Let's say I want to perform some transformations, and let me just check the data. So the data is, let's say, overview, sample data. Where is the sample data? Table, sample data. Oops. Click on sample data. Okay, so this is the data. Let's say I just want to pick the amount which are greater than $1,000. Okay, let's do this. So I'll literally say where amount greater than 1,000. Let's say I just want to apply this particular transformation. Make sense? So this is my select statement. This is my query, SQL query, pure SQL query, and you will see the moment you will run this particular file, run this model, it will create the table with the name called demo, because the file name is demo. If you change the file name, you can also change the table name. So I will create a table called demo, and it will be created inside this catalog stg, not stg, inside this catalog dbt tutorial, and there will be a different schema called dbt underscore a lamba, because that's what I just defined, and it will create that table automatically. Wow. Yes. So now how can we just run this model? So first of all, you need to open the terminal like this from the bottom, and this is the scene. See, this is a rendered code. This is saying that you have one model with name called demo. Wow. So if you have some dependencies, it will automatically create that dependency DAG for you. Simple. You can also click here in the code. If you click on compile, it will simply compile your code, whatever code that you are going to run. It will simply take some time. It will compile it. Then this is the compiled code. You will say, Ansh, but this is the same code. Yes, because you have not used any kind of variables, any kind of Jinja. When you use Jinja, then you will see the difference. And if you just want to preview, you can click on the preview. So it will simply show you the, you can say, preview version of your data. We have some error. So it is saying extra input limit. Okay. Database error in demo model, runtime error, limit 500. Okay, makes sense, because by default it simply limits the data to 500, and it is not allowed in the preview. So that is fine. And we just need to click on, you can also build it, but it is not required here. You can simply say run model. And now what it will do, it will simply run the model directly from the terminal. So one deprecation is found. That is fine, just a warning. And here it will simply check it, and it says one success, one deprecation. and it is simply running this. Okay, so it is completed. If I just click on this drop down, I will see that this file is completed. This run is completed. Now if I just go to Databricks, if I just refresh, I should see that schema. So yes, I can see DBT Lamba, and I can see one demo table. Wow. Wow, 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 wow. Is it a table or view? So if I just go to details, oh, this is a view. Why it is created view? But we will just debug it. Don't worry, do not worry. But this object is created for you. This object is created for you. That means you have literally defined what you want in the select statement, and it created the entire table, entire view for you. Did you write any kind of DDL command? Create view, create table. Did you just tell like in which format you want to just create the table? No, nothing. But it created everything for you. How? Using that particular thing. Wow. Literally wow. Makes sense? So this is the power of DBT. And now, yes, we want to just debug like why it created view and not the table. Let me just check. So if I just go here, so we have here table applies to all. Oh, makes sense, because we have defined this property to this project, but our project name is changed. So I have to give this project name that we just changed here. So I will simply say this thing. And if I just save it, and if I now rerun that model, run model, now it should create a table for me because view is already there. Now it will create a table as well. So let me just see. DPT run, selected ammo. Okay, it is completed. Now let's click on the schema and let's refresh the schema from here. So I can see now this demo is a table. Very good. Now I can see it is a table. Makes sense? See, it is a managed table. Very good, managed table. So that's how you can actually do the work, and you will see the transformation as well. All the amount will be like more than 1,000. See. So did you write any PySpark code? Not at all. Did you write any DDL command? Not at all. Did you take care of any kind of partition strategy? Not at all. What did you do? Literally just write your simple select statement and that's it. Boom. This is good for like simple transformations. But when you just want to perform critical tasks like incremental loading, slowly changing dimensions and all of these things, then it becomes a big task. Make sense? So this was all about your DBT, and now I know that you want to learn DBT in detail, but I have provided you both the best options. First is documentation, second is that full course that you can just watch, and that's it. Okay, very well done. Your DBT detailed session is done. Now I want to talk about one more thing which is very important, which is called slowly changing dimensions. Now analytics engineers need to understand this concept seriously. Now let's talk about this concept, slowly changing dimensions. Okay, so whenever I just talk about slowly changing dimension, one thing is like very clear by looking at the word changing dimensions. That means, let's say I have one table, and this table, let's say, is a product dimensions table, products dimension. And you can just imagine that we will be having columns like production ID, surrogate key as well. So production ID and production product name and product category and product subcategory, whatever, all of these things. So let's say we have these things inside this product dimension table. Perfect. But the problem is, what do you think? Do these attributes will remain the same? For example, today the product name is anything. Let's take the example of noodles. So today you have actually stored the product name as noodles, but let's say tomorrow you want to save the name as, let's say, magic noodles. Obviously you can just change the name. So one thing is very clear, that the data that we are storing in the dimension tables can change. It is a very common scenario, right? So if the data will be changing, then how are we going to handle it? Because see, This is the data table which is built on the data warehouse side, or basically the Lakehouse side. And we might have pulled this data from a SQL database, and there we will be having a lot of information like, let's say, product ID, product name, right? And most probably there will be a separate table for category and subcategory. It can be, but let's say only this information is coming from this products table. Okay, products table, simple products table. So this is my data source, and now I am creating this dimension using this table, which is a data warehouse. But now in the recent transactions, I have changed the value for this product name. I have changed this value. In that scenario, I have to just take some action so that I will also reflect the changes in my dimension table. Make sense? Because this dimension will not remain the same. That is why it is called slowly changing dimension. It will be changing slowly. And whenever we just talk about slowly changing dimensions, we have to talk about the types of it. By the way, there are 6 types. And again, we do not use all the 6 types. We hardly use till type 1, type 2, and sometimes type 3, and that's it. We do not go beyond that because it's not very easy to manage and maintain these types. It's very easy on paper, but when you actually maintain it, you will know the pain. Okay, so let's say type 1, type 2, and then we have, let's say, type 3, and so on, like type 4, 5, 6, so on. But we just talk about type 6 till type 3 till type 3. We do not go beyond that. Simple. So let's say like this. Okay, so now let's talk about type 0 as well. What is type 0? Well, type 0 is like also called as non-slowly changing dimensions. Type 0 means your data will not change at all, which is a very rare scenario. But in some cases, it is the situation. For example, country codes. Country codes would rarely change in your data. I don't know why would someone change the country code. They can, but in some scenarios, you can just consider country dimension as like non-changing because country information will remain the same. Sometimes people just change their country name. I don't know why, but they can. Okay, so in that scenarios, like in those scenarios, you can just do that. But in some cases, they can be treated as like non-slowly changing dimensions. Simple, good. But yeah, so we have type 0 as well, which is like non-slowly changing dimension, so we do not consider it. So now let's talk about the type 1, which is the most easiest type, and you already know about this type. You will say, Ansh, Lamba, no, I do not know. You know this. How? Remember, I talked about a concept called upsert. Yeah. So that is type 1. Or I can refine my statement that we use upsert methodology to perform type 1 slowly changing dimension. Really? Yes. Now I want to explain this concept. Okay. And let's take some help from the online documentation. Obviously, there's no official documentation for slowly changing dimensions, but slowly changing dimension is type of a concept in itself. So we have some like good papers on Wikipedia. So I'll simply say ICT types. Hopefully this will give me the Wikipedia page. Thank you so much, Benj. Thank you so much. Edge. It is renamed. So now see, I told you that we have type 0 as well, retain original. That means the data will not be changed at all and it will retain as it's in the original form. Simple. So it is good when you are sitting in the interviews, they can just ask you what is type 0 and you will like, what is type 0? So it is not actually a type, but it is actually a type. So, okay. For example, date of birth. Now, obviously, someone's date of birth will not be changing, but sometimes they need some correction. Maybe they would have entered wrong information. So it is a kind of correction, not changing. I hope you are getting the intent. You are not actually changing something. You are making a correction so that we do not consider it as like change. Okay. So the type 1 is called upsert, or we also consider it as override. What do I mean by this? For example, let's take the example of products table, or let's take this example as well. This is also a very good example. Let's say you have one table for supplier. You have information such as supplier key, supplier code, and supplier name. supplier name and supplier state, like in which state the supplier is like performing all of the operations. Perfect. So let's say till 2025 December, the supplier was in California. Okay. Now, starting January 1st, 2026, the supplier was moved to a new state. And now the supplier is working from EIL. There's a very weird name. I can just search it, like Illinois, something like that. Illinois, yeah. Illinois. So let's say now supplier is working from that state. So there's a change, right? So do you know what we will do? We will simply overwrite the value. And what we do in upsert, we simply update the value if the value is already there. So that is why whenever we just talk about this type 1, we simply perform upsert. So for example, in our case, let's say if product name is changed, then we will simply change the product name and that's it. And you already know that we can perform upsert. So now if the product name was changed from noodles to magic noodles, now you can simply put the new name, which is magic noodles. Simple. This is the most simplest type of slowly changing dimension, and this type will be used in most of the cases because it is very easy to maintain. But do you know what? When you are dealing with some complex data sets, or you can say you are building solutions for domain which require some history as well for your changes, then you cannot rely on type 1. Why? Let's say I want to see the previous name of my magic noodles. Can I see it? No. So in those scenarios, I need a system where I can just see the history as well. For those things, I have this type 2. So for type 2, we keep the history as well. History of records. Okay. The entire history. Like what was the first value, then second, then third, then fourth, like all of the changes. But Ansh Lamba, if we will just store the history, then there'll be like redundant records. Very good point. Very good point. But do you know what? Whenever we talk about type 2 slowly changing dimension, yes, we create redundant records, but we also create a kind of flag that says that this is the current value which is in use. For example, let's say within this product name column, I have two values. One is noodles and second is magic noodles. Now, I need to tell my users that which value is the latest value, right? So I will simply create one flag column like this. Let me just copy this thing here. And here I will create one column which is called flag. Or you can also call it as like in use or is latest, anything. This will be like flag. This will tell me that if this is the value is in use or not. Noodles value is not in use, that means flag equals to no. Any previous value, all are no. Only the latest value will have the value as yes. So I will simply use this flag every time I am just querying my data. Simple. And along with this flag column, we create two more columns as well, which is called as created at, or let's say updated at, or from or to, basically like when this value was changed and till what period. So from date and to date. That means, let's say noodles. Noodles was the name of the product from which date? Let's say from 2020-0101. Okay. And when it was changed on 2025 31st of December. Okay. So we need to keep the track that which value was in use from which date till what date. So I hope you got my point. So you need to, yes, store the history with dates as well. So we create these three special columns. Make sense? Okay. Perfect. In use flag, from date and to date. Now, if we just try to see, let's see if they have just covered this thing in detail. Type 2, add new row. Yes, very good. So in type 2, as I just said, that I just add new records. Why? Because I just want to keep the history. I will not update the record. So this is a very good example. So here you will see that here I have the first version as CA. That means California and Illinois. okay, as a second record. So how I will just create a dimension on top of it, I will simply say that, hey, this was my original value and this is the start date and this is the end date. Then new value came into the picture and the start date is this one, and this should match with this one. When this was ended, this was started, and this is null. Why? Because this value is still in use. Makes sense? Because obviously this value doesn't have any kind of end date. Now some people just like this null section. I do not like it, so I simply put a very high value, let's say 9999 12 and then 31. What it tells, it will simply say that this value will be expired on 9999, which is like very big date, because I do not like keeping nulls in my data. So this is like a kind of alternative that you will see in most of the organization, but the intent is the same. You just need to put a date that will say that this data, this record is not expired. Simple. And I think they have also written it here. A standardized surrogate high date, see, may instead be used as an end date. Very good. They have also referred it. Wikipedia is actually a very good thing whenever you just want to read something. So you will see this kind of behavior as well. I also prefer this one instead of having null, but intent is same. Now you will say, Ansh, Lamba, where is that column flag? See, some people prefer keeping the flag column. Some people will simply use this date. If this date is like this thing, 9999 1231, that means this date is still in use. And or if you have null, simple. And if you have any lesser date than this one, then obviously this date was expired. So some people just prefer keeping just 2 columns, but I prefer keeping 3 columns just to have a one flag, because it helps the data analyst to simply filter down the records quickly based on some logic. Okay, just one toggle and it is done. So this is type 2, and I hope it makes sense. The advantage of this particular type is you can literally store the entire history. Let's say now I have this supplier in a new state, let's say in LA. Then what will happen? There will be an end date for this one and there will be a new record inserted within the table. Very good. Now let's talk about the type 3. What is this type 3? Type 3 is actually similar to type 2, but not exactly. Type 3 will say, I will also store your history, but not entirely. I will only store the previous value of your change, and that is it. If you do not want to store entire history, if you just want to store the previous value, then you can go with type 3. What will type 3 will do? It will simply create a new column, and in this new column, it will store the previous value of the change, and that's it. And it will update the recent value. Let me just show you. So type 3, where they have, oh, see, they have also covered this in current flag in the below example. Very good. And the third method uses an effective date and current flag. So they have also used it. Very good. So type 3 is add new attribute. Attribute means column. So now this time we simply add a column. So as you can see that here I have just put this particular value, which is original supplier state California. But now the current supplier state is IL. So what I did, I simply added one column. Wow. Makes sense? So you simply save the previous value here in the original and current value here. So you simply maintain only just two things, previous and current, and that's it. Okay, makes sense. And it is also written here, an additional column has been added to the table to record the supplier's original state. Only the previous history is stored. Only the previous history. Make sense? Okay. But now this record contains a column for the original state and current state. Cannot track the changes if the supplier relocates a second time. This cannot be tracked. Okay. Make sense? You can only track the one previous change and that's it. You cannot go like two steps ahead, like 2 steps before. Okay, these are the top 3 types that we use in the industry. Type 4 is like, let me just show you. Type 4 is like adding a history table where you just simply create the history separately. Like you will just have your supplier table as it is, with the latest value, and a separate table for history, which is not a kind of good thing. You are like duplicating the tables basically, and it will be a mess when you will just draw the data model. So instead of doing type 4, people directly prefer doing type 2, just store everything in the same table. Simple. Why to create a separate table? Why? Doesn't make any sense. So it is written, type 4 method is usually referred to as using history tables, where one table keeps the current data, the latest data, and an additional table is used to keep record of all of the changes. Make sense? Very good. But both the surrogate keys are referenced in the fact table to enhance query performance. Oh. Now you can also say that it is a combination of type 1 and type 2. Yeah, kind of. Yeah. Okay. Then we have type 5 and then type 6. And to be honest, you will only see the solutions till type 3 and that's it. If you just want to understand it just for the knowledge purpose, you can obviously do it. But when you are just doing it practically, then you will either create type 1, type 2, most of the cases, rare cases, type 3. That's it. Because people either want to see the entire history or not at all. They just want to see updated data and that's it. This is the concept of slowly changing dimension, and slowly changing dimensions used to take, I would say, at least 100 lines of code at least in PySpark and Spark SQL, same, because we just use both whenever we are building slowly changing dimensions. But with DBT, we can directly create slowly changing dimensions using snapshots. We have a special feature in DBT called snapshots. You can learn it. Okay. Snapshots will simply say what is your key column here and what type of slowly changing dimension you want to perform. You want to perform type 1, just tell me. You want to perform type 2, tell me. It has written the code automatically behind the scenes for you. You will simply say type 1, type 2 and that's it. You do not need to do anything. Simply put everything in the YAML file and that's it. So yes, DBT also takes care of this particular complex concept which is called slowly changing dimensions automatically. This is one of the biggest advantages. Simple. So this is all about slowly changing dimensions. So this is your analytics engineering masterclass, and I think we have covered so many things. And actually, I hope now your concepts, your ground understanding of this entire data lifecycle is very, very strong. You know how to perform which thing and when. So I hope now you have gained strong knowledge. Now let's talk about your learning pattern that you can just follow quickly. So I would recommend you to just go through each thing step by step in the same order that I have discussed. I have also shared some of the resources along with this video. Simply go with those resources. And by end of completing all the topics with all the resources, I hope, and obviously with practice, you just need to practice, you just need to build some projects, you just need to build something on your own. I hope that you will be able to actually sit confidently in the interviews, will be able to crack offers, and you will be able to grab the position which is for analytics engineer. I'm so sure, because all of these skill set will actually make you the analytics engineer. Do not try to skip anything. You will say this is not required, we do not need to do this. See, you just have two options. You can either deny the fact, okay, or just face the reality. Reality is you have to learn, you have to learn new things. This change is coming here, I know, with a rapid pace, but this is the reality. Just think about the people when internet came into the market. No one was ready for the websites, no one ready for the web applications, no one was ready for the applications, but people started adapting with the change, and now you are seeing the entire ecosystem built. The entire IT industry boomed because of those people. Now we do not know how future will look like, but what you can do, you can literally adapt with it. AI is here, start learning AI. These changes are here, these infrastructures are here, start learning these things, and that's it. We do not know where you're gonna go. You can only just adapt the changes. Make sense? So simply try to learn whatever you can, and rest is up to you. And I hope you loved this masterclass. And if you love this masterclass, simply drop a lovely comment, like the video, share this video with your friends so that other people, you can also help other people. Okay. And you can just share this YouTube video everywhere you want. And I will see you in the next video. I will keep on helping you. I will keep on guiding you, and happy learning. Bye bye.